is the most powerful weapon we can use to change the world. Now, the person who has consumed himself to change the society and light the darkness in the life of many students. I am profusely elated to take an opportunity to welcome Dr. K. Gunasegaran, Professor, SRM IST, to deliver the welcome address.
Thank you, madam. அனைவருக்கும் இனிய காலை வணக்கம். Very good morning to all of you. It's my immense pleasure to welcome all for this international webinar on Precast Concrete Technology, organized by Department of Civil Engineering in association with Universiti Malaysia, Sarawak, Malaysia, and also with Indian Concrete Institute, Chennai chapter, Association Consulting Civil Engineers, and UltraTech Cement Ltd. We welcome the guest of speakers. Today we have 3 speakers. First speaker we have today Dr. K.P.Jaya, Professor, Division of Structural Engineering, Department of Civil Engineering, Anna University. Also, she is the Director Research for Anna University. I can proudly say that I was a student of her when I did my PG. I welcome you, ma'am. And next we have Engineer Er.Amit.K.Barde, Head Precast Institute Ltd Limited, Technical Service, Building and Factory in Charge. On behalf of Department of Civil Engineering and on behalf of HOD Dr. P.T. Ravichandran, the convener of this webinar, I welcome him, sir. And then we have Professor Muhammad Abdul MANNAN, Professor from University of Malaysia, Sarawak, UNIMAS, Malaysia. And he is going to present about a topic on precast formwork. We welcome you, sir, on behalf of Department of Civil Engineering, SRM University, on behalf of the convener, Dr. P.T. Ravichandran. Then I welcome all the coordinators of this webinar, Dr. P.R. Kannan Rajkumar, Dr. L. Keshla Raj, Engineer A.P. Murugan from UltraTech Cement Ltd, Head Technical Services, Ms. N. Ganapati Ramaswamy and Ms. C. Pavitra. Last but not the least, the participants, both from national and international research scholars, faculty members, students, and practicing engineers from industries. Once again, we welcome you all for this international webinar on Precast Concrete Technology. Thank you. Thank you. Over to Pavitra.
Gunasan sir, no, Amit sir has joined the program, sir.
Okay. Amit sir.
Yeah, hi, good morning, everyone.
Very good morning, sir. We welcome you on behalf of the Department of Civil Engineering and head of the department, Dr. P.T. Ravichandran, convener of the program, and all other coordinators and all other speakers. We welcome you, sir.
Thank you.
Pavitra, madam.
Thank you very much, sir. Thank you for your provoking address. You have set a perfect platform for our webinar. It is on occasion like this we get opportunities to test our knowledge and understanding. We look forward to get an exposure about what the best of the brains think about. I take a honor to invite Dr. L. Krishnaraj, Assistant Professor, SRM IST, to introduce our speaker, Dr. K.P. Jaya, Professor, Division of Structural Engineering, Department of Civil Engineering, Anna University.
Ma'am, my screen is visible?
Yes, sir, it's visible, sir.
Anevarukkum vanakkam. Good morning to all here. It is my privilege to introduce Dr. K.P. Jaya, ma'am, Professor, Division of Structural Engineering, Department of Civil Engineering, College of Engineering, Dindi, Anna University. And she is playing many additional responsibilities, as I mentioned by Professor Dr. K. Gunasegaran, sir. She is a Director, Center for Research, Anna University, Chennai, and Associate Editor in Journal of Applied Engineering and Sciences, published by Anna University. And she is also an Executive Director in Building Technology Center, Anna University. And she was the first chairperson in Indian Concrete Institute, Chennai chapter. And she is a panel member of CED 39, Earthquake Engineering course in IS standards. And she is an independent director Tamil Nadu Police Housing Corporation since 2017. And Jaya ma'am has won the Outstanding Concrete Technologist Award in 2020 from Indian Concrete Institute. And she has won the Best Woman Engineer in 2019 from Institute of Engineers, India. And she is a member of Board of Studies in many universities. And she completed the consultancy projects more than 2 crores. And she has published 2 books and more than 150 articles in peer-reviewed journals and national and international conferences. And she has guided 12 PhD candidates and she is currently guiding 7 scholars. And she is a professional member of scientific and professional societies. Welcome, ma'am. And she is an eminent personality and well known in India and globally with her excellence in academic, administration, and research. And thank you very much being part of us, ma'am. Thank you, ma'am.
Thank you for your introduction.
Thank you.
Hello.
Yeah, thank you, ma'am. Thank you. Pavitra, ma'am.
Ma'am, we welcome you, ma'am. It's over to you, ma'am. You can share the screen.
Yeah, thank you for the long introduction. That itself become a presentation. Okay, I'll share like this because when I put slideshow, it's not visible to me. May I continue with this?
Okay, madam, no problem, no problem. We can continue, madam.
Yeah, thank you. So my topic today is challenges in precast construction. So before entering into that particular topic, I just want to say why precast. We are very familiar with the monolithic construction, what is happening in and around in the society that we are very much familiar with. But we need to, what I can say, think about why we are going with precast. Look at this particular slide. See, think about the demand for housing. In Indian scenario, at present, around 26.53 million units is a requirement for accommodating our own sisters and brothers to have their own inhabitant. But after 10 years, we are expecting around 50 million units are the expected requirement. How we will do with the normal monolithic construction? Now itself, we are facing the situation like major issue. What we are facing is lack of skilled workers to execute the project. See, this is the normal way of constructing beam column connections, and we are putting the partition walls with the brick or brick masonry structures and all those things. There were skilled laborers available when the demand was less. But now the demand is too high. We don't have any such availability of skilled workers. So what is the solution? We have to go with some mechanized construction. This mechanized construction generally nowadays we are calling as precast or prefab construction. See, look at this picture. Change is inevitable. We cannot go away from accepting the factors. Change is inevitable. In 1980s, see our computer and see the look of ours. Now in 2013, even now it is changing like this. Look at the picture on the right hand side. Earlier, people were very much fond of reading newspaper in the morning, even standing in the street. Now, what you can see, even people are just crossing the road with the headphone on ears and not even hearing the horn sound of the vehicles. They are passing by. This is the change. Change is inevitable. We are accepting that fact also. So we have to adopt to get along with the precast building. This is a typical view of a precast building. And you can see all the structural elements of these precast structures are casted in the factory and assembled in the site. Look at this beautiful picture. This is a Jubilee Church at Rome. All these shapes has been inculcated into the structure through a precast technology. So they are casted in the factory and strip by strip. Each Each element has been cast in the factory and brought into the site and properly connected. Even now, this structure is very strong. It is almost around 30 years over, 30 to 40 years over. This is the Golden Hill Park at Singapore. So cute to see. Now, they are doing a lot of work in Singapore, Malaysia, and all. They are doing a lot of work using the precast technology. And there are a lot of challenges also. Their consumption of reinforcement is also comparatively less compared to what we are using as of now. That means we have to do a lot of optimization in our design also. And look at this, we are not away from this technology called precast technology in India. This is the historic representation. In India in 1959, we have a building, IOL building in Chennai. This old building is constructed out of precast elements. But unfortunately, later part, we identified that there are some portions wherever the water accumulation is there, the water percolation leakage has been observed. That is the major reason behind abandoning this technology from taking forward in the construction industry. That has a long last past history. Now there are a lot of presence in precast technology in India. Look at this. This is the Vikas Sauda in Bangalore. The whole element, the whole structure has been constructed out of precast structures. This has been executed by BG Shukhe in Pune. They are the pioneers in this area along with L&T. And they were also working in this particular area in the precast technology. They have a very good factory. I visited twice or thrice. It's a very technically sound laboratory, what I can say, factory they have. You can see this. This is the site arrangements. When we were talking about the precast elements, and it will be cast in the factory and it will be brought to the site. Now you can look at this particular site arrangements. What is deficiency, what you feel like? We need, if we want to execute a precast structure, we need sufficient space around, or there will be some restrictions in the execution of the precast structural elements. Accordingly, we have to plan our execution process. See, for any project, we have to do all these things like SWOT analysis, strength, weakness, opportunities, and threat. There are few strengths like speed, low maintenance, seismic resistance, all those things are there. Along with the strength, there are some weaknesses also, lack of awareness. Many of our engineers are not aware of this particular technology because we are not teaching them in our PG program or UG program. And later part in 2006 onwards, we are in Anna University teaching precast technology for our PG students. Yeah.
Pavitra madam,
Yes, sir.
please take care about that participants. Some of them are unmuted.
Okay, sir. I'm not the host. Sir.
Okay, just a minute, madam.
Okay.
Jagan, sir.
Kannan sir. Kannan.
Sir?
பாருங்க சில participants unmute பண்ணிட்டாங்க இடையில.
சரி சார். Okay.
Follow. Sorry madam, sorry for the internet.
No issue, sir. Okay. So because I can't raise my voice, that's why I stopped. Okay.
Okay.
So opportunities, what are the opportunities? We have a huge requirement of houses. So once we start venturing into this precast technology, we can come out with the demand for houses. It's a very huge requirement and shortage of skilled labor. That is an opportunity to execute this precast technology. Large size projects we can execute, exposed to global market, because we are very much aware of this PCI code and all those things, because this precast technology is accepted globally. So we can expose, we can venture our market into that global scenario also. Demand for quality construction is an opportunity for us. Threat, as far as possible, we know what government tax policy and bad past experience. As I told you, like IOB building, we had a bad experience. So that has been become a threat to us and vested interest. I'm not a person to talk on that. Lack of standardization, that is very, very important aspect. When we are going with a mass housing project, we can execute the project with the precast technology with the cost controlled cost. But when you are thinking about individual buildings with the residential building, with each and every building, the separate plan, separate elevation, then there is a threat. There is a threat how we will execute, and casting each panel separately in the factory is difficult. So there we have to think about standardization. There is no harm in constructing building which look alike. That is my policy. Then there will be a lot of imaginary problems with engineers. Once we start learning something, we will not come to a conclusion that, okay, this is the solution. So that is the imaginary problem. So, but once we start thinking about learn swimming, we have to jump into the water, then only we will learn swimming. That is my policy. We have to venture into that and find out what are the problems and solve. We the engineers are there to solve the problem. So that is the threat we can solve at any cost of. So before entering into the challenges, we should know what is the damages experienced by the precast elements. I'll just browse through as pictures. You can see here, this is the performance of precast parking unit in 1994, Northern earthquake. This is the Turkey earthquake. And you can, one common phenomena I'll discuss at the end. This is a Bucha earthquake. You can see the school building has been collapsed. You can see columns are intact, beams are intact, planks are intact, but the structure has been failed. That is the major observation. Structural elements were intact, joints and connections were failed. So the major issue with the precast structure is the poor connections. We need to do more attention. We need to give more attention towards that. That is the challenges in precast constructions with respect to the connections. What are the different connections? Column to see, these all connections are like our body. There are connections in our bone. Knee joint connections, shoulder board connections, are all knuckles in the fingers also are connections. Each and every connections has to perform perfectly. Then only we can do our work without any difficulty. In the similar fashion, precast structures also have different varieties of connections, and each and every connection should be ductile as well as strong enough to maintain whatever with the service load, it has to be taken care of. Here you can see column foundation connection, wall foundation, beam column, column to wall, beam to slab, and wall to wall connections, and stair to slab connection. These are varieties of connections are there. You can see here, these are the column to foundation connection. These are the base foundation. From there, the column, the reinforcement are protruded outward, and this is the sleeves, 12 sleeves with 60 mm diameter, which will be embedded within this column. These sleeves will be embedded in the column, and this reinforcement will be housed in these sleeves. This is the way. Look at this major challenge here. It cannot be major variation in the positioning of the reinforcements. And all these things to be perfectly arranged, then only the connections will be proper. This is not only one connection. For a small building itself, there will be a number of columns, a number of foundations. All these should be housed properly, then only the execution will be comfortably happen. And these sleeves will be filled with non-string grout through the holes which is provided at the top of in the side of the column, and it will be sealed afterwards. This is one type of mechanical splices connection to column to foundation. And at the base of the column, we can have a base plate connected, and the bolt can be protruded outward from the foundation. And this is what is called base plate connection. This base plate connections is very much common. People can easily do. You can see here, this is a practical view from the site. This is the foundation. From there, the bolt will be protruded and the column will be placed with the base plate and nut and bolt will be connected. And this protruded area, this pocket will be covered with the non-string grout in later part. And finally, it will look like a in situ constructed foundation column connection. This is another way of connecting the column to the foundation. This is a pocket and this is a column with the shrimps at the bottom, and this portion, this cavity will be filled with a non-string grout. Based on this particular thing, column to foundation connection, one of my scholar has done this work, Ms. Mamadi. She submitted her report and she is about to defend on that. These are the different types of connections she has been adopted. Precast column to connection through the base plate. This is the anchors coming out of the foundation and the base plate connection. And this is the sleeve, grouted sleeve connection. She has put, you can see here, this is the sleeves. You can see here, this is the view of the area where it will be grout has been inserted later part. And this is the pocket connection. There she has used two type of connections. One, the pocket, wherever she is inverting this column, this is the pocket. There she has put a reinforcement all throughout covering the pocket together. This you can see here, this is starting from one point to the other point, and these two elements has been connected together. And in this area, independent, all these walls has been connected with the independent reinforcement, and later part at the joint region, it has been connected together. These are the two type of pocketed connection she has done. And this is the view of the load setup in the laboratory. And she has done a lot of investigations. This is the cracking pattern. I'm showing this to give a clue that in what way we can execute the research and come out with a solution. And finally, we identified that the pocketed connection with the totally wounded reinforcement all around has been performed better for a low-rise building. Now come to the next type of connection, beam column connection. This picture has been taken from the Elliott's book. It is a very good statement that has been made by Elliott also. You can see here, here the column is continuous and beams are discontinuous. And here you can see the column is discontinuous and beam also discontinuous. If we think about a better option out of all these things, the connection A or B may be better, but what is lacking there? We cannot cast a column of multi-story height columns, casting in the factory and bringing into the site and erection is a difficult task. So finally, people will be going with this type of connections. Which one? C type, all elements are meeting at a particular junction. So always junctions are dangerous. Here also it is dangerous. So we have to provide proper connection detailing. These are the various type of connection detailing without corbel. We can go through. This is the beam passing through the column. Column is discontinuous and this is the dowel protruded outwards. These are the major challenges in the precast construction, like this protruded bar should properly inserted within these column sleeves. That is the major challenges. So that is why I am telling that is a threat that we need to go with standardization. So this is the beam column connection with the corbels. You can see here, these are the corbels and these are the beams getting connected. And this is the very simple, very safe connections, because the dowels will be protruded outward from this corbel region, and this reinforcement which is protruded outward can come to the columns also to get a proper view. This is the beam column connections. Again, it is going with the hybrid or emulative connection. In this case, whatever be the, you can see here, the beam has been cast. This portion is precast and the stirrups are protruded outward. Later part, when it is connected to the column, this particular portion where the stirrups are protruded outward will be filled in with cast in situ concrete. So this is what is called the hybrid or emulative connection. We assume that we can achieve the strength in similar to that of a monolithic connection. So this is another type of hybrid connection. This has been generally followed by Shirke, BG Shirke. There they are using a cavity sort of thing. This is a double column connection. This is a shell. And after erection, this interior portion where the dotted shade is there will be filled in with the in situ concrete. This is the way they are constructing the beam column connection. Here, beam reinforcement, which is protruded outward, will be bended into the interior of the column, and they will be connected together like this. And this is the longitudinal reinforcement continued through the column region. And this entire portion where you have seen the hatch with the dotted hatch will be filled with in situ concrete. And this is the longitudinal view of hybrid connections. And this is the actual practical view. This is the column. You can see here, this is the protrusion projection outward. And on top of this, the column, the beam edge will go and sit. You can see, you can visualize that in the next picture. So what has happened here? This is the cavity. There you can see the protruded reinforcement also. And the main reinforcement, longitudinal bar will be connected, pass through this top region, and it will be casted as a single unit in later part. This is a picture which has been taken from Metro Rail Station, Kalamassery. This has been done by the TeamH Coimbatore. And one of my research scholars, she has done a work on beam column connection. She has done a lot of connections, and we have published papers in the AAC journals. These are the various type of connections she has taken for the under consideration. Tie rod connections, and this is the cleat angle connection with you can see here, this is a cleat angle which is connected here. We have connected with one rod here, another rod here, and this is another thing with a single stiffener. We have put this one stiffener also. We have tried one by one. Whenever we couldn't reach to the strength up to the monolithic joint, we have did lot of improvisation. That's what it's shown here. That we have used double stiffener also here, and this is the double bar which is coming out of. That's what I told. This is a better solution. This is a corbel. This is a double bar coming from the column region, protruded through the what I can say corbel, and the hole within this beam can be housed through this bar and rest on the corbel, and later part it can be mounted with the nut and bolt. And this is one another method. This is the method what we have tested in the laboratory, and these are the specimens she did what I can say numerical analysis also, and we identified that this type of connection has given more performance during lateral loading methodology. Now comes to the column to column connections. This is very, very important connection in any precast structure. This is, you can see here, 1 minute. You can see here, this is the upper column and this is the bottom column. And this particular region, when we are casting, if we are delaying the casting of the in situ concrete in these regions, this reinforcement should not get rusted. So we have to be much careful when we are going with this type of connections. This is the column to column connection with the bolted base plate bolted connection. You can see similar to that what I told you in the foundation column connection with the base plate. You can see here bottom column will house this protruded reinforcement, and top column will have base plate, and it will be connected together. Later this portion will be grouted with in non-string grouts. So this is the typical beam column. 1 minute, let me try this. I have, yeah. Video is viewable.
Yes, ma'am. Yes, ma'am.
This is a video I taken from Chennai Silks Velacheri site. I think whatever I told, one scene it is clear. Am I correct?
Yes, madam.
Yeah, this is nothing but connection. Slab to wall connection. This particular picture I have taken from L&T. L&T person is here. This has been given by Saha. This is again, you can see here, this is a slab to wall connection. You can see this particular portion is in situ concrete, and this particular projection outward. There is a purpose for this particular projection. Is to avoid the percolation of rainy water and to permit it to flow downwards. That's why they have provided like this. Due to the demand or requirement of architects, they have improvised that and changed into this particular shape and size. You can see here the projections has come down, has been reduced to this shape, and this is protecting the percolation of water to the interior part of the building. One of my research scholar, Ms. Dr. Aradi, she has defended and she got degree also. And she has done a work to wall to slab connections. She has used many types of connections like double bar connection, provision of the crossbars, and additional shear reinforcement. She published 4 papers in International Journal, and she received a Best Paper Presentation Award in NIT Calicut also. She is a very good scholar, and she has done a very good work. This is the monolithic specimen what we have kept as a benchmark element. Gunasharan sir.
Yes, yes, madam.
How much more time? 5 minutes I'll get?
No issue, madam. Please take me.
I think I have crossed my time.
No issue, madam. We
2
can
minutes,
manage.
5 minutes, I'll finish it off.
Okay.
Yeah, this is what I can say. This is a wall to slab connection. You can see here, this is the upper panel and this is the lower panel. And we are getting connected. This is the cross section of the precast element. You can see here, it is 2 layers of, because if I'll take long time, you can see here, this is proposed types of precast connections. This is the precast element. This is particular area we have provided the screed concrete. There we used, you can see here, this is a wall to slab connection elements. And here wall to wall double bars, we have provided 1 double bar like this. And this is the bar which is getting connected with the reinforcement. Here also we have provided a, what I can say, U-hook sort of thing. And here another U-hook sort of thing. This is the second type. And this is the precast element P2. Here, 1 continuous bar from bottom wall to the top wall, and another U-hook here. And here, this is the precast specimen type 4. We have provided a nib sort of him here, and 1 bar is going like this, and protruded through the precast element, and it has been connected. This is the 4 types of connection she has studied. And this is the methodology what is done in the site. You can see here, these are the double bars what we are used. And 1 observation we made, I'll tell you in long run. This is the casting of the concrete, and later part we placed in position, and screed concrete has been poured. This is the final view of this is the bottom panel, and this is the top panel of the wall, and this is the slab where we getting connected. This wall, this slab has two parts: bottom precast and top cast in situ. And this is the arrangement in the laboratory. This is the specimen double working jack and all these things. And this is the loading protocol. And these are the historic loops we got. And these are the failure pattern of all these things. The major observation initially we got is there is a splitting up of cast in situ bars, slab and precast slab. Our suggestion, the major suggestion based on this particular study, we should provide shear reinforcement in between the cast in situ and precast slabs. And these are the studies she has done on precast. You can see here, this delamination of two type of slabs has been very well picturized in the numerical analysis also. Exactly same way we could picturize in Abacus software. And these are the, you can see here, this lifting up of the slab, exactly we could picturize in Abacus. So these are the work out of all those things. What we observed that shear connector, this the last one, which is protruding through these slabs, has performed very well. See this one with the U-hook connecting through the slabs has been performed very well, and the edge also we have stiffened accordingly. This is a slab to beam connection. You can see here, these are the slabs and this is the beam. And from the beam, you can see the protruded reinforcement. While providing a screed concrete, this slab reinforcement will bend on either side of this beam and bend it along, bind it along with the screed reinforcement before pouring. You can see here, this is a site of one particular precast site of the image. And this is one of the beam slab connection on video, is small video. Now you can see here, I am projecting the wall-to-wall connection from the picture from the side. You can see here, this is one wall to another wall connection, and we have to provide intermediate loops in between these walls before and pour the concrete. You can see here, this indeed is the joint region. We are pouring the concrete at the later part after connecting the wall together. You can see the view of it. So this is the connection region. You can, and later part, provide former outer side of this connected detailing of the reinforcement, and the concreting will be poured after placing the walls. And we are using sometimes, most of the time, we are using these type of loops or the reinforcement bended. Like there are a lot of work happening at IIT Madras with the I forgot Amlan Sengupta and Dr. Maher Prasad. There are many work happening with respect to this wall-to-wall connections. And comes to the later part, so finally, nobody is giving importance for this stair connections. In seismic analysis also, nobody bothered about, but we have to bother how to connect the stairs with the slabs. And these are the stacked staircases. And this is an overall view of a typical work site. But if we get a site like this, yes, we can enjoy like anything. But it's very, very difficult to get a site like this with an open space. And so we have, so this typical site, we can be happy. And look at this, there are a lot of complicated plan. So none of the plan is similar. So this also can be executed in simple way using precast technology. Now look at this very limited working space. You can see here, this is the boundary. And here also, this is the boundary. You can see this compound wall. It's very difficult to work with a complicated limited working space. You can see here, very, very limited working space. And here you can see, so this is a very simple single span, large single span. And that is the advantage. We can go with the pre-stressing also when we are thinking about a large span requirement. So this is to the concluding end of my lecture. And I want to show you that we have published, Indian Concrete Institute in 2014, we have published a precast concrete book, and it is very informative. That has been contributed by many eminent people from IIT, SARC, L&T, and Anna University. So you can go through this book, and I am happy to say that I have authored 2 chapters in this. And there is another book by Precast by BMTPC that is also giving a lot of important information related to precast construction. If anyone want to go through, you can go through that book also. This book I can share with these organizers, but that other book, this book is not for open public what I sharing. So this I can share with the organizers for the benefit of the all listeners. So promotion of the precast from my side, what I am doing is like carrying out research in the connections. 3 scholars completed PhD, 5 scholars are pursuing, and I authored 2 chapters. And I have delivered lectures at various locations. So I'm so happy to share my thoughts and my views of precast to any August gathering. Thank you so much. Thank you all.
Thank you. Pavitra madam.
Yes, sir. Yes, sir. I'm there, sir.
Okay.
Any questions?
Yeah.
The questionnaire forum is open.
There is a question in chat box, madam. Please go through.
In chat?
You can read that version.
Yes, sir. I'll read. Yes, ma'am. I'll read it for you.
Madam, before that, I have one question, madam. Like a conventional concrete, is there any effect of grade of concrete to be considered?
So minimum M30, I suggest.
Okay.
Minimum.
Okay.
We do with M30.
In your presentation, you have shown a lot of challenges, especially on junctions, different elements.
And one more thing I forgot to tell, I thought of putting a last slide. I am dedicating this presentation to my beloved friend, Mr. K.P.Jaya, who was the editor of Master Builder, who was the person promoted precast. And he was behind the publication of ICA precast concrete book. My presentation I am dedicating to Mr. K.P.Jaya. He is no more now.
Yes.
He's late K.P.Jaya, and he is the person who brought me to ICA. And when I have opted to choose to write a chapter on connections, then he was telling me like that is the heart of the book, and you will be known as a connection person later part.
Yeah, that exactly true, ma'am. But in your presentation, you have shown a lot of challenges, as I said earlier, many connection problems.
Yes.
And parallelly, you have done that work on Chennai sets. How that was carried out, ma'am? Is there any design connections or already the guidelines are there?
As of now, we don't have any guidelines in IS code. We are using all PCI codal provisions.
Okay, ma'am.
To some extent, and all connections we are designing based on the resultant forces coming at that particular joint.
Okay. What is your yes,
there is some special software available, but I am not depending on that. Most of the teenagers buildings, I am only getting the connections.
Okay.
All full design. I'm only waiting, but most of the time, what I suggest and what I do, I will take the force components, force resultant at the joint region, and I will design according to the requirement and our bars requirement and whatever the main reinforcement requirement. I will design and I'll wait. That is my policy, and that's what I'm telling. We should include all these things into our IS code provisions, and only it will be benefit for our community.
Okay, ma'am. Okay. What is your suggestion for people like me, emerging people doing some material side? If you wanted to start the precast area also, where we'll start first? We'll concentrate the element
Yeah, you
as a
can
new
think about
as a new
elements. You
as a
can think about
newcomers.
elements.
Okay, ma'am.
And especially what I suggest at the starting level, you can think about the slabs.
Okay.
The challenges are less.
Okay.
When you are thinking about a slab, you have to design the slab according to the load coming at that particular level only. Correct?
Okay. Yes, madam.
In
Correct.
that particular floor. So
Okay.
if you are designing, start designing as an initial stage, when you are thinking about a slab for a residential building, we know that the loading is only within 3 kilonewton or 2 kilonewton per meter square. So there you can fit in your slabs with a new material property. Okay. Later part you can think about it, but thinking about column and foundation, I will not suggest now at present.
That's what, madam. That's what. Yeah. Slowly you can build up.
Yeah, slowly you can build up and you can think about it.
Thank you, ma'am. Thank you, madam. Madam.
Very good presentation, Dr. Jaya. Superb. I attended the international seminar with the Dr. N. Subramanian from the States in Bangalore 5 years back. There the focal point was the joint only. Now I am greatly relieved that you have given a solution for it.
Yes,
in fact, we are adopting the precast square walls and all for coastal walls. The housing board also recently did some Toubro project with the precast technology. So slowly catching up. If there is a support from the government, I think it's a need of the hour. The quality maintenance, all these things. Except the road bridges where the reinforced earthwork has got a precast panels. Recently, Metro is also adopting the tunneling, the precast panels. Slowly is catching up. Thank you for all these inputs on the, especially on the connection joints. A great achievement, and the days to go, it will become very popular. Thank you, ma'am.
Thank you, sir. Thank you so much.
Good morning, ma'am.
Yeah, anything? Anybody else?
Yes,
Yeah.
ma'am. This is Dr. Asha from St. Peter's, ma'am.
Yeah.
As an academician, we don't find any simple textbook for the design of connections in the precast, ma'am. Can you suggest anything for so that will benefit the students?
As of now, there is no book. You can refer the book published in the ICI.
Okay, okay, ma'am.
And I am about to write a book.
Thank you, ma'am. All the best.
Then I will give a book to you.
Sure, sure. Welcome.
Thank you, ma'am.
Yeah, anything else?
Precast India Pune has done a lot of work in the IT part. There, we can get some details from them also.
And
on the connections.
Book, you can refer the BMTPC book also. What I have shown.
Okay. Yes.
Madam, there is one question in chat box. Whether intelligent building can be constructed using precast technology?
Intelligent building, yes, of course. You can embed whatever be the intelligent element into that during the casting of the elements. It's possible. Definitely, it's possible. Instead of you are embedding all these intelligent element in the casting into concrete, you can embed it during the casting stage of the precast elements. Nothing wrong in that. It's possible. Only one question I have.
Pavitra, madam. There is another KRS.
There's one more question from Ganga, sir. That is, ma'am, whether intelligent building can be constructed using.
That's already answered.
Yeah, that,
Okay, sir.
yeah.
That's it, sir.
Question, sir.
Yeah. Yes, sir.
Yes, sir. Jagannathan.
Yes, sir. Actually, making precast fully RCC may be difficult little in junctions. Why can't we make it as a composite structure? In junction, we can have some base plates and the boards and nuts to join.
Yeah, it's possible, sir. I have presented that also, sir. At the junctions, whatever my student has done on mechanical connections was not up to the markings, not up to the, what I can say, strength categorization of the monolithic connections. So what we suggest, like, it can go with the hybrid connections.
in
Partly
beam
precast.
resting of beams and resting of columns over these slabs. At that junction, we can make it as a composite structure so that that part can be steel in the base to hold it in the boards, and we can grout it.
You are talking about steel concrete composite?
Composite, yes.
We can try that, sir. Not at all an issue, but cost is the main concern.
Actually, initial cost may be high.
Yes, sir.
Anyhow, it may be.
And we are just trying to avoid even billet connection also. That is also a composite connection. I didn't show in this my presentation. Billet connection is a very strong connection, but it is too costly. In India, we are not started manufacturing that type of connection detail elements. So it will become very costly to import, and that's why we are not adopting that as of now. So that is the main concern, sir.
Thank you, madam.
Sir,
Madam,
I'm from SRM.
SRM, madam.
I'm from industry. I came from railway.
Okay, sir.
Now I'm working here for last 10 years.
Okay, nice to see you, sir.
Madam, one more question from Nigeria. He is my first student of PhD scholar, Dr. Adibakit.
Okay.
He is asking, is precast concrete possible with lightweight concrete, since you suggest minimum grade of M30?
As of now, I will not suggest lightweight concrete.
Okay.
As of now, why? If you are asking me why, I don't have an answer now.
Okay.
But I will not suggest as of now lightweight concrete. I will not suggest, sir.
Okay, madam.
I take a great privilege to welcome Mr. Ganapati Ramasamy, Assistant Professor, SRM IST, to introduce our next speaker, Engineer Er.Amit.K.Barde, Head Precast Initiative, Larsen Toubro Limited, Technical Services, Building and Factories. We welcome you, sir. Ganapati sir, it's over to you.
Thank you, ma'am. Ma'am, my screen is visible to you?
Yes, Ganapati.
Yes, sir, it's visible.
I'm very happy to introduce our chief guest, Mr. Er.Amit.K.Barde, and he's a head in the Precast Initiative at L&T Construction Technical Services, Buildings and Factories in charge, and he is actively involved in developing and promoting the precast technology. And Er.Amit.K.Barde has a decade of experience in the precast construction industry in the United States with a leading precast concrete manufacturer. Engineer Amit is known for his expertise in the variety of residential, commercial, and industrial precast concrete building in India for the last 8 years. And he is a member of ICA as well as PCA and Indian Concrete Institute. He is a licensed professional structural engineer in the US, and he is a certified professional in US Green Building Council as well as LEED. And we are very happy to welcome you, sir.
Yeah, good morning, everyone. Thank you for that introduction. I think we'll start with the presentation.
Yes, sir. Yes, sir.
Yeah, I'm just going to share my screen. Yeah, it should be visible to all now.
Yes, sir.
All right. I think camera, I just turned it on just so that everybody can see the face. I'm going to turn it off later. Thank you for inviting me in this seminar. Thank you to SRM University. We have a wonderful crowd here. Looks like interesting presentation by Professor Jaya already. My goal today is, after that presentation, is to see just to showcase our precast projects, what L&T has been doing for last 10 years in this industry. So I will try to keep it, avoid repetition, and the focus throughout this presentation will be more on case studies of some of our flagship projects. mainly in the residential space. That's the focus of presentation today. I am going to just give a flavor of all commercial projects, also what we've been doing in last 6-7 years, some of the interesting features on those. And then we'll get into what the way forward would be for the precast technology we think in India, both in the residential as well as commercial space. So that's how we'll pretty much progress. Of course, if you have any questions, we will discuss those separately at the end of the session. All right. So broad agenda, I think this screen is visible to everyone, right? I just changed the camera off, so I'm not sure. Screen is seen? The screen is visible or no?
Yes, sir. Visible, sir.
Yeah. Okay. All right. So broad agenda again. Need for technology. Professor Jaya already has discussed that. So I'm just going to quickly run through it. Maybe some of the different things that what we perceive. The design philosophy. I'm going to spend some good time here. I think most of the college students. So that would be an interesting topic. Again, the design philosophy. What we are doing mainly in the load-bearing wall system for residential housing. The case studies that I mentioned, these Pragati Towers and the Provident Sunworth project in Bangalore. This is one of the 2 flagship projects we have in the mass housing sector, like large volume in residential. While I explain these case studies, we will cover on the precast technology, how the production works, how the construction is going on, what are the different challenges that we are seeing. We will touch base on quality control, quality assurance in here. Mainly the discussion would be around how we look at the water, moisture or air infiltration, how to deal the joint or how to detail the joints, right? You usually hear that the devil is in the detail. Where it comes to precast technology, you have to say that the moisture or water is in the detail, right? If you detail it well, that whole myth that leakage, precast joints, moisture seepage is not there, right? Last 6 years we've been developing that, and we are at a very comfortable place now where we can have buildings that perform equally to a conventional system. Once that we will go through this, one of the large now newly started project, just about 8 months into it in Navi Mumbai, where we are taken about construction of about 8,000 houses using this precast technology. So we're just going to go through that. And lastly, as I suggest, the way forward, what we think the future could be. Now, when we look at precast technology, this picture sums it all, right? Whatever the demand India is seeing, we are looking at large housing. This is not precast housing. This is one of our cast in place housing projects, but this was 1 lakh houses. So that's the kind of scale what we are looking at. That's the kind of answers we are looking at to provide for the need that the country faces, right? We all are aware of the Housing for All initiative. What I wanted to pinpoint mainly is this was probably the first time when the government formally acknowledged that there is a need for technology. So far, it has been going through the private sector saying we need to do something different. But this initiative, when it was launched, this technology submission that is in these documents is one of the first acknowledgement from the government side saying, you do something different. If you are doing something different, we will encourage that, we will support that, right? What are we doing? We are not doing anything new. Most of our neighbors have done this already. If you see Singapore, Shanghai, Tokyo, Hong Kong, they've all gone through the same challenges. They've all gone through these housing situations. What is unique to us is, if you see, they've all done this in a year, 20-25 years time frame. We are looking to do the same thing in about, or actually larger scale, in about 7 to 10 years. So that's the challenge that we have. Again, in terms of infrastructure, have you not done this already? If you see your metros, your airports, your high-speed railway now that we are building, already latest technology is in there, right? We are establishing. If you look around Mumbai right now, I have high-speed rail project going on. I have entire metro development going on. We have coastal road development going on. In one city, there are 3 landmark projects going at the same time with the latest technology. Most of the situations that probably not even the European or Western world have experienced, we are using those. But if you look at housing, somehow that has not translated. We are still mostly using the conventional means. 95% of our construction is still built using conventional methods. And if you see outside, the only way, or the one of the key things how the outside countries have solved this problem is by mechanization. So when I say precast building, that's not the only solution. Any mechanized building, anything that works on a mass scale, maybe may be PEB, precast. Precast works well because our population is used to concrete, right? There is a huge comfort in concrete, or seeing that brick and mortar building. So that's how the precast is becoming popular here. So if you look at that end user, and what they want, this is what the key four things. We talk to a lot of them, we do the surveys, and we see what the customer want, what the end user want. Again, government is not the customer, the people who stay in there are the customers. And these are the four main things that they would want from a technology. As long as they get those, it does not matter how you build it to them. So they want a house that's a status symbol. They want something long term, not something that will stay for 5-10 years. They want that house to be given to their families. They want low maintenance. That is one of the key agenda on them, because okay, whatever the housing prices and all, the government is there, their main worry is, will I be able to maintain that house? I don't want this additional burden, because I get the house at a very encouraging price. And of course the resale value is, it should be acceptable. So tomorrow if I need to sell it, somebody should willingly come and take it off. And so that's the basis behind what we also look at when we evaluate different technologies, or all these, I think, college students, if we are going to go, and next 10 years we are going to evaluate various technologies to get the rapid construction in place. These are the key things when it comes to housing you should be aware of. This is what your end customer wants. Now what we have done, if you see, this is pretty much the history of L&T. We have been doing conventional construction, like I mentioned, since last 50 years. In the 90s, we experimented with tunnel formwork, right? This rapid construction demand is not new. We have been doing this day in, day out for several years. If you explore the way technology works, this is even today's date, this is by far one of the fastest construction method that you are going to see. It works even faster than precast, but it works for very boxy buildings. There are very stringent layout requirements that usually are not accepted by the end customers. Rectangular buildings, or very rectangularish layouts, what does not usually work in Indian construction. Then in around 2000, we started doing aluminum formwork. This quickly become one of the most popular construction methods now when it comes to rapid construction. In residential construction in L&D, 95% of the projects to date are being constructed or have been constructed using the aluminum formwork system. To an extent where we, within L&T, we own probably about 6 lakh square meter of shuttering. Usually that's a huge number. Since COVID, the construction pace has slowed a little, but if you look in 2018-19 timeframe, across the country, we were building around 400 towers using this system. That's how it was popular. In 2010, the management felt that, okay, aluminum formwork is there, it's popular, but the kind of demand that we are going to envisage, this speed also is not going to be enough. We are looking at a cycle time of somewhere around 10 to 12 days. Actual construction, maybe on paper it is 6 to 7 days, but you have issues, site, everything. If you consider the actual result of aluminum formwork system, you are looking at a 10 to 12 day cycle. And they said, this is not enough, I need to do something else. I need to do something much faster, 30-40% improvement in productivity. So that's how we ventured into precast system in 2010, and we've been exploring that for last 10 years. Now in the residential sector, the experience that we have, you have to know, this is a very unique client. Most popularly known as a commercial building, you have one client. If it's a residential building, you have 4 clients per unit you sell, right? There is a family. So if I'm looking at 8,000 houses, I will have 32,000 customers, that kind of deal. So you need to know, you need to have that enough experience, and we've built that. So this technology kind of have evolved out of our experience. We are not a precast concrete manufacturing company. We have selected precast concrete out of our own needs, understanding that whatever you are doing is not going to be enough. So what I wanted to drive here is, especially for the budding engineers, the building design does not come on its own, right? It's not just putting walls and columns and pouring concrete. A well-designed building has to be looked at, invested for various parameters, especially if you're looking at mass housing, right? We are looking at building 100 buildings 20-story tall. You have to look at the cost, speed, what the end user wants, what are the bylaws, what are the structural integrity requirement on the design. And with all those parameters, if you work together, L&T is one of the very few contractors who has his own in-house design firm. I used to be in the design field. Now I've moved to the BU side. But one of the few contractors who have all design engineering teams, including the structural design, architectural, MEP, CMPC methods. So we get that one unique solution, and that's how the precast technology at L&T has been evolved over the years. So the client gets one answer. He's not going because you are doing precast. What do I do at the MEP? And we don't say that you go to a different consultant. The solutions that we are looking at, which will probably over the years set the industry standard, look at all engineering aspects. Now, before we start going further, one thing point that would be key to note is we have usually two different systems. One is beam column system in residential construction, which is what we have been doing for several years. And then the new rapid construction, what we are looking at, usually the aluminum formwork system, the tunnel formwork system, or this precast. They come under this load-bearing shear wall concept. If you see these pictures, you are going to see that obviously these buildings are going to be slightly more expensive compared to your buildings, because the structural core, where the RCC, which is your most expensive system, is very nominal, less than 50%. In this picture, this is everything concrete. Right? So you are weighing that, you are willing to put that extra amount in the building construction. See, client is going to pay the same thing, right? So from our side, we are putting this extra because we get the advantage of speed, right? In here, if you see one floor done, your building is only less than 50% complete. In here, one floor done, the work 90%, including your MEP, conduit, routing, everything, 90% of the work is done. All you do is do some nominal internal block work and painting, finishing, and hand over the building. That's why the aluminum formwork or precast technologies are getting more and more popular. One other thing, the end user maintenance items that I mentioned. Once you have the beam column system, by definition, you will have blockwork plaster. Nowadays, we are having external systems, finished walls. But the whole idea behind is, I don't have internal or external plaster or finishing when we have the RC buildings. These are cast in the metal molds, may it be aluminum formwork or precast system. They come finished. It's M30 minimum grade concrete or above. It's going to last there without these maintenance issues from both internal and external. So this is one example. This is our own project. And what you see is, especially for the mass housing or this government housing, where the maintenance budgets are not sufficient. If you see this building, the first story was done in cast in place, and the above is precast. This is a 9-year-old building which has been handed over. And if you see the plaster and all this, this was actually year 2 and year 3 where it starts fading, spalling. The paint is going on because the plaster was never meant to be a long-lasting element, right? It's a finishing element, but it absorbs water, absorbs moisture. Moment water gets into that, you're going to see the paint fading and all. Here, it's an RC grade concrete. The paint has not been retouched for 8 years, and this picture was taken about 6 months ago. So in 8 years, that building has stayed the way it is. So I'm not going to go into key details or advantages, but in general, I want to put it out there that whatever that you will get in RC aluminum formwork type buildings, you are going to get the same benefits in precast, plus the advantage of speed and quality, which comes at the factory quality control, right? How about the design now? What do we do when the precast design comes into picture? So even in the structural philosophy, like I said, there are two main things. We are probably going to focus on the large panel system that we proposed for housing. Then, of course, there is beam column system and the separate research. I think Professor Jaya has already covered a lot on those connections. So when it comes to load-bearing wall system, all you are looking at is dismantling your building into as many 2D elements as possible. Those are easy to manufacture, easy to transport, and then pretty much just take them to the site, assemble and stitch it. What we call it stitching is the wet concreting to connect these two members together. So there is no rocket science, but from a contractor or a rapid construction perspective, if you see, the top notes the conventional construction system where you have formwork, reinforcement, concreting, then you come back and do your block work, plastering, POP work. What we are doing in precast is mainly we are just eliminating this block work, plastering, POP work, which takes usually a lot of workforce, takes a huge amount of workman activity. And then whatever the key activities or the cumbersome activities are left over, those are done at a factory. Then you transport the element and finish at site. That's where your advantage of time is coming. Structural design philosophy wise, now if you look at the conventional beam column system, what we used to do is right here. So we'll have beam columns, gravity elements, there will be some lateral shear wall elements which will take your wind and seismic lateral load. What we are proposing here is by default we are saying most of the walls are going to be your load bearing members. Some of those walls will be shear wall elements, and that's how you design the building. It has its own redundancy, right? So in earlier system, if you see, we used to see that progressive collapse requirement, and if one column is damaged, your entire large area is in question. In this area, if one small portion is damaged, there is still several walls are there to take care of that element, so that redundancy is better. Now with that system, now how do we analyze the precast system, right? What codes are saying? This is one thing I want to stress with everyone. In precast connections, there are two different school of thoughts. One is the emulative approach, which says that basically you detail your system such that it will behave equivalent to your monolithic RC construction. And then there is jointed approach connections and welded and bolted connections. So before I came to India, all 10 years I was doing only welded and bolted connections. Nobody is doing emulative approach there. Why? Because it takes time. There is wet concreting involved. It's more expensive to do it there. Welding and boltings are easier. Second is usually they don't build tall, right? Usually buildings you will see is 12 to 15 story, not more than that. More than that, usually steel is cheaper there. So that works well. Here we are building 23 story, even we have designs for 30 story, where the emulative approach works well, even if it comes at a slight cost of time, that site activities, but performance and design is similar to conventional. So that's how we have taken all our residential projects that you see. They're based on this emulative approach. If anyone is interested, there is actually this ACI document 550.1. There are various revisions also, but this is one of the best guide from American Concrete Institute. And what that says is basically emulative detailing provides structural performance that is equivalent to structural performance of a monolithic concrete structure, right? Equivalent, that word is important. So you do your detailing well, and then you construct. Once it performs equivalent, then you are not worried how it will respond to earthquake. It's going to respond to similar to a conventional building. What that means is basically you can go back to your 456, which is the most involved code in India, and adopt the same code for the design principles. Of course, we have 15916 specific precast code. There is now 11447 also is one of the older codes which is under revision now. Those give precast specific details, but they are not industry popular. Mostly when it comes to concrete building, everybody is going to run to 456 for the design principles. So if you do this emulative detailing, you can adopt that code and still go with those principles. Now, if you look at the PCI, they even took one step further, saying not only equivalent, this emulative detailing is applicable on any seismic region. This was done in 2000, and plenty of research has been there behind. And earlier, if you see state of California, which is known for huge earthquakes, they were not allowing precast except for gravity members. They still used to do shear walls using cast in place. But based on these research, last 7-8 years, they've opened up where precast shear wall examples have been done as well. Apart from your lateral design and all, what you will do usually is what is the structural integrity connections. The rule of thumb has been your each element has to be connected to at least 3 adjacent elements. So if you see your slab, it's connected to 2 additional slabs and the beam or the column. If you see this column, it is connected to 2 beams and the slab. So that has been the industry rule. There are requirements. If you see this, even IS 15916, this specifies now for all these minimum rule of thumbs It is a prescriptive design, what all ties you have to do and the forces or what the steel to be provided. Those details are available in Indian codes now. Now, quickly looking at that structural integrity or emulative or the equivalent performance I mentioned, right? So that was there, but when we started, we wanted to validate that at our end. So what we did is, this was a program done in 2015 in conjunction with IIT Madras and SERC Chennai. So what we did is we did a full scale, full height shear wall element. This is a 3-meter tall wall element, two shear walls together, if you see this picture. And then this entire element was cast monolithic using whatever conventional details that we do. And then we did 3 different specimens using the precast joint. This is what my key joint is when it comes to shear wall, which is your key element to resist lateral loads. And what the
Sir, Amit sir, your audio is muted, sir. Please check that.
Yeah, can you hear me now?
Yes, sir. Yes, sir. You can. You can.
Yes, sir.
Okay, I'm not sure how long, but I think
Last minute, sir.
Okay, all right.
Just from this slide only. Just from this slide only.
Okay, all right. Okay, I think they muted everybody. So all right, I'm glad. For a minute, I thought, I don't know how long it was muted. So anyway, coming back to, so the idea of this program was, this was, like I said, I don't know how much was muted, but this program is done in conjunction with IIT Madras and SERC Chennai. And the idea was to compare that emulative detailing, what we are saying, if it works or not. So we made one specimen with the conventional detailing. If you see this specimen, this is all cast monolithic using the foundation walls and the top slab. We even simulated the top 10 to 15 story dead load on top of it. And then this actuator is a reverse cyclic actuator. It pushes and pulls the element with the base fixed. So it kind of mimics that cantilever shear wall. And then we wanted to see is, if conventional specimen behaves in a certain way under the exact same condition and same loads, how will your precast elements with this horizontal joint will behave. And we had 3 different elements with 3 different types of connections. All of them were giving me this emulative detailing principles, and we wanted to see how it works out. And this graph kind of sums it all. Now, there is an instinct usually when people see this graph saying, oh, this is your cast in place and this is how the precast elements are behaving. But SW1 wall is my cast in place shear wall. So this is what the cast in place response was. This is your force versus displacement. Area under the curve is going to give you that ductility or R value. But more than the R value, again, the idea is whether that detailing is giving me performance similar to conventional wall for a cantilever shear wall. And if you see this SW2 and SW3, they are pretty much following the same path. So we are getting the same ductility, same response from the structure. If the area on the curve, it's more or less same. This wall is different. We use the grouted couplers to make these connections that you see here. So this is one of the very popular systems used in Europe and Western worlds to make your connections, the grouted coupler system. And why it gives better performance than even conventional system is, this conventional system still has detailing based on lap. So your lap connections are governed by your concrete around it. And the principle is, if that concrete around is confined, that's exactly why we do the horizontal shear loops and all, to confine the lap bars. If it's confined well, it will give you better performance. And if you see in this grouted system, this metal sleeve is confining that grout. So if you want to visualize this, your precast panel is going to be here. You have this coupler. The next precast panel bar, that's a male bar that goes into the female part, and then this is grouted together to make that continuity. And because this is confined well, even more than your what confinement effect that you will get in conventional RC system, it produces better response for the same steel that is being developed, right? And how this is tested is also interesting. There is a code to it. They call it type 2 connectors. If you see this, it's not just a pure tension pull out test. What it does is it's a tension and compression. If you see, it's full tension and it's pushing the bar down also to compression levels, and it will do that for 20 cycles, then pull that bar to twice the yield, do 4 cycles, it will pull that bar further to 5 times the yield, and then it will make it to failure. So that's where that ductility is getting looked at, right? This is again that same area under the curve, we are going to get ductility. But the key thing is, after doing all this, this is pretty much mimicking your seismic reverse cyclic loading seismic effects. After doing all this, the bar has to fail in ductility, not in the coupler. That was the idea, and that's what exactly what you will see in this phenomenon. It's a high strength grout used. The bar yields, fails, there is no brittle failure. This is exactly why you saw that higher ductility response on that last wall, which give the performance even better than conventional system. Now, this I'm going to run through quickly, but that one point I wanted to drive, when you look at shear wall connections, especially what we are doing is actually working really, really well. So we did another test program where we looked at even the diaphragm action, how the slabs are collecting the loads and transferring to the shear wall. Again, full scale specimens, and everywhere we are getting more than satisfactory performance, and the validation that the detailing what we are using is actually seeing. If you see, this is also the same what discussions we had is CIP concrete precast slab. That delamination also, what the kind of detailing what we see or what we have used, we did not see the delamination effect. We had the according to the forces and all, the detailing was done right. Same for the vertical shear wall joints between two panels. Again, for that shear we tested, then validated. So the entire system, what we are proposing for this load bearing shear wall for housing, that key connections have been validated in house. All the details, emulative detailing has been there in place for last 50 years. People have been using it outside. We have not evolved or done anything drastically different. We have probably tweaked it to suit our requirements and then adopted it. So the next phase was getting the approvals from various agencies, and this system what we use is now BMTPC approval is there, which is what gives the fast track adoption in all government projects. Of course, IIT Madras, we work very closely. All our projects, Dr. Meher Prasad and his team, they get peer reviewed by them line by line by default. Of course, IIT Bombay also has reviewed it. IIT Delhi has reviewed it. We have College of Engineering Pune, VJTI Mumbai, all leading institutes. They have gone through it in detail, what details we are doing, and we are there ready to use it in any large scale projects. I think time wise, I am already slightly behind. We will just go through the case studies quick, and then we'll open it for questions. These two projects I wanted to mainly focus. G plus 23 story, about 70-meter tall buildings. We built 6 buildings in Mumbai. This was one of the first projects that we did, about 2,000 houses. In the pictures, you see 3 towers. We built another 3 towers later. So total 2,000 units there. This is what the Providence Sanvat project. It's this came in 2013 timeframe after we did this. This is 66 buildings, about 6 million square feet built up area. This was about 1.2 million square feet on the scale. And this is much larger project. We have handed over phase 1 and phase 2 already about 3 years ago. And then some of the commercial buildings that we will go through. Provident, I'm going to spend little more time since we're running out of time, but various awards already in place. Even ICI award, the Mumbai project, we got the first, ICI started one new precast award, and we got the first year's award for that Mumbai building. But this one certificate, it kind of talks, and we are more proud of it than anyone, because it came extemporary from the client for the speed, right? That G plus 12 building was constructed in 3 months flat. That's the speed advantage you get from this technology, where a conventional construction would go for at least 5 to 6 months, if not more. We completed that in 3 months at peak. So this is the project snapshot. These are the 4 phases that you see each band, and we have completed 2 phases. The balance 2 are under works. This one thing I wanted to put it there, saying The first building that I showed Mumbai, that was the PMAY housing or SRA building, all units same and smaller units and typical. In this Provident, this was pretty much like a sale building. These sale units, two types, whatever is there in the market or any traditional housing that you will get to see, the same was taken. The same was adopted without any changes, and we kind of wrapped the technology around it, right? First year, the developer was saying that, okay, whatever precast I adopt, I'm not sure how the users will accept it and all. So they were not actively marketing it. 2 years down the line, this is from their brochure saying advantage of precast, and they're telling people openly saying, I'm building this in precast, I'm proud of it. They even gave another job in Chennai down the line. So that's how that adoption has come over the years on the technology. So these are some of the pictures that during construction, and these are some of the finished pictures. If you see buildings when they're done, the whole philosophy behind pushing new technologies, the end user should not see anything different. So the whole idea behind detailing execution is, once the product is finished, even our engineers may not be able to tell exactly where the joints are, how it's finished, or how the building. For them, it's a finished flat. If you see, this is one of the finished buildings. It looks exactly same the way they would have expected. Even if you walk inside the building, you are going, this is the sample flat was built, that was also built using precast, and the way it's finished, once you walk inside, you don't see anything different than what you're used to seeing. That is the goal, right? The factories are set up, the whole advantage of technology what we have been pushing is very few people. If you see our factories, you won't see an army of people working. This picture is not taken on Sunday, it's a working Wednesday. There'll be gang of 12 people, they know exactly what to do for the day. Whatever 30-35 elements they want to erect, they will erect. There is no material stack, no machinery in place, very minimal setup, and they will do the same thing day in day out. Second thing, the speed depends on how many number of cranes you put it. If you see aluminum formwork, it depends on how many number of sets you can put it. That's an expensive affair, that's a capital expense. Here my factory is already sized. If I want to open up another 2 towers, all I have to do is just rent one crane, put it, factory is already sized for that production. So that's the advantage. The quality control what we see is this, like if you see Bangalore, this factory was not even did not even put the shade because it doesn't rain there. But that does not mean the standard quality is not followed. We still have the same quality measures, same quality parameters that you will use on any conventional site, but you are working on a ground, right? In tall buildings, working on a ground versus working on a 17 story is altogether different ball game, in terms of both for the workmen, also for the monitoring. Somebody has to climb up there and see. Here the person is roaming around at the ground level every day. He's looking, checking everything in detail, and then only approving it. As far as service is concerned, usually you will see that all MEP and plumbing conduits, everything is embedded in the panels. Usual practice is electrical directly gets embedded because it is very low maintenance. Once it put there, you never really have to worry with it. Plumbing, we keep it open or undersunk so that the access leakages can be addressed. So either you do this undersunk, this developer agreed to that, it works well. It's easier to repair also than the sunk areas. But if you want something embedded, we do the chases for plumbing lines. So this is how the panel will come. Electrical is already embedded, but plumbing you give the chases so that the piping is laid and then patched. So later if you want to have the access, all you have to do just open up the patched area easily, replace your pipe or rework it, and then close it. Transportation and all, I think in 2012 and 13 we used to talk a lot about transportation and how to do heavy elements, but over the years now there are standard trucks available, there are equipment available. It is not a big deal to transport a 10-ton element anymore, except the road network. So we don't have that kind of infrastructure yet. So what we usually do is large scale factories are set up at the site only, so I don't have to worry about transporting for longer distances. When the elements go outside, the same quality control, same like I said, the well-trained gang of 12 to 15 people, they know exactly what to do. They don't have much to do also. Elements come from the factory ready. You just have to prep the slab, make sure all levels, lines are maintained, the dowels, whatever you want are there and correct or not. You clean the joint, erect the panels, align them. We have these push-pull props. Make sure that the joints are grouted, put your slabs, and then do the slab concrete pour. So that monolithic pour, what we say is, all these slabs will be erected, and then entire floor will get a continuous cast in place structural topping, 75 millimeter thick, that acts as a diaphragm that gives me the continuity and the stitching what we are looking at. So yeah, this is the job. This is how the architect had envisioned in 2013. This is how we have finished it in 2016-17 time frame and handed over. This one job quickly, just to give a flavor how we adopt different. It's a very small job. Usually we don't even venture into these jobs, but this came up that they needed it in 8 months. This is a hostel buildings for Tirupati Devasthanam. So they were originally G+3 systems. They were designed for 2 extra floors. The kind of speed what we were using, client said that add the 2 floors also immediately, because they were not sure if 3 floors will be completed in time. So the design philosophy was build 3. I start using the hostel and then add 2 floors later. But with our speed and whatever system we had in place, they said add the 2 floors and finish the building. So this is how it's done. It's a small building. We had 4 or 5 buildings. What I wanted to show is 2 unique things. Now here, because the founding level was less, we had the rock in about 1.2 meter. We did even the plinth work in precast, right, just to save time. So all you see traditionally, what you will do is foundation, plinth, your backfill, and then precast starts at the first level. Here, because the system was low, this is the raft top that you see, and even the plinth walls were built in precast and completed. Then the backfilling was done. Now, if you see this building, about 1200 square meter area is there. Conventional time will take at least 20-25 days, including all activities, everything. RC work itself will take 12 to 15 days, form work, shuttering in ground, water and all. This picture, what you see, the entire footprint was installed in 3 days. Right, all these wall panels were installed in 3 days after the raft, and then backfilling for another 6-7 days, your MEP routing, and the plinth was ready in 15 days. So that's where we are looking at the advantage of time. The second thing wanted to showcase is this building, small building, but they had a dining hall at the bottom and then the rooms above. So they wanted open spaces for the dining hall. So what we did is, we did this as a portal frame. So this is a transfer beam which carries the above 5 floors and gives me this open space. It's a 7 meter long beam, and this was done as a moment connection. Usually we do simply supported connections because moment connections are difficult to achieve. It takes time at site, but because they wanted this open space, simply supported beam would have been at least a meter deep. When I get the moment capacity at the end, this was fitting in 700 depth, which was fitting in the building height. So we did that. This is a moment frame. This is a secondary beam which needed corbel. And now see how we work with the architect depending on the system. So I technically only needed corbels on these 2 sides for this and this beam. But then the architect, we sat together saying I have to have the corbel. Then we came up with this shape that worked well. Then he said, okay, for symmetry, if somebody is sitting here, why don't you add this corbel? So this corbel was added more for architectural. Then we took the benefit out of it. But this corbel was added to get that architectural impact, and then they were going to put these gods and goddesses photos on this when the dining hall is complete. So that's how it was worked. They said, I will work with your corbel, but you give me this extra corbel. And it looks very, very clean and nice. This another example, Cognizant Technologies job in Pune. Beams column system and hollow core, 8 to 10 meter base, and that's where the hollow core system works well in commercial buildings. Same way in Mumbai, we did one parking structure. This is a building in Bangalore, Wipro, where only this facade was done in precast. Yeah, like I said, I think we are again, we are not in the precast manufacturing business, but wherever all our jobs, we have various jobs going on. The idea is wherever that system will give me the benefit of either speed or less activities at site, we adopt that. So even this is a small portion, doing this band in cast in place, shuttering everything, compared to that, all this cast off site, erected at site element by element. That's the idea, and that has kind of picked up really well in last recent 5-6 years. This one example is the IKEA stores we did in Navi Mumbai. This is opened now last year. Slab looks tiny in picture, but this is 16 meters long span. This is one of the longest in India hollow core we have done using steel structure. 400 thick slab, 75 screed on top of it. 75 screed on top of it, and this was designed for a warehouse load of 750 kg per square meter. So you have the span, you have the load, and still these hollow core slabs worked well. The floor was completed in 50% of the time that was envisaged for conventional construction. This one now we are doing currently now in Vizag for a substation building. But if you see here, this is where we have done now 2-story tall columns. These are 12-meter tall columns. So that saves me time, and we are getting that continuity. The other beams and connections are designed to get that monolithic and moment frame capacity. But very fast-paced job. This is another job where these facade elements are done precast. Right, so building is conventional. Facade, entire facade, which was envisaged in block work, we converted that. About 2,000 elements in the job. About 1,000 is done already, and all they have to do is just paint it now. No plastering or anything. Just treat the joints and paint it. Same thing we are now exploring in a job in Mumbai now. This is a 27-story tall hotel. Entire this facade is planned in block work. Takes huge amount of time. We converted 2 floor-to-floor tall precast panels. Each panel is being erected under 30 minutes. So you imagine it's a 4.2 meter tall panel, 2.3 meter wide, and 30 minutes to erect it, and that's the speed we are looking at site. Pre-finished has been a big thing for us. So Mumbai, all residential buildings, even one of the topmost elite housing buildings, we are using now the bathroom pots. So the idea is, again, pots are cast in the factory, entire toilet unit finished, everything at the factory site, no activity at site. Lift it, place it, and then it just gets opened once the site nears the handover phase. No other work in toilet is done at site. I think, Professor, how are we doing on time? About 5-10 minutes more?
Yes, sir. We can go ahead, sir.
Yeah. Okay. All right. So now I am just at the end of that presentation. How we do system we have talked, design philosophy we have talked. I've shown what we are doing at site, how we are setting up the factories. This now is the handover stage, that how I give it to the client. So usually the client speed, everything is contractor's issue. He's not worried about it, except he gets the building faster. But his main worry long term is, okay, how the building is going to perform, whether I'm going to have cracks, or under earthquake the building will fall down, or day-to-day services, whether the moisture, water is going to get inside. And we have been working diligently on that detailing, like I said, to make sure that the buildings perform similar to what we are used to. Now this building, what you see, is not our building. Before we see this picture in 2016, we used to claim that we have built the tallest building in Mumbai, which is 70-story, 23 levels. This is done by Shirish Patel in 1972. So it's more than 45 years now. In Mumbai, right next to the coast, which is whatever your harshest environment for the building. The building has been standing tall with nominal maintenance without any issues. Total precast, wall panels, hollow core slabs. Each flat is about 15 crore plus value now. It's one of the prime real estate area, and occupied building, they don't have issues, right? Maintenance is there. One of the facades, they see the moisture seepage and all, they treat it and work with it. So if you look at the detailing and all, the whole durability, or whether the joints will sustain and all, those questions are not there. Building is in zone 3. It has seen fair amount of shaking, if not active earthquake on its own, and it's in pristine condition. So you detail well, you maintain well, these buildings will last forever, right? This is M30 above concrete. It's not your usual plaster. That actual concrete grade that we use based on our factory requirements is usually M45 to 50. So the concrete stays there. What we have to do is attention to detail on the joints, work well, make sure all your quality QA/QC is focusing on the joints. Rest of the QA/QC is taken care in the factory. So this is the picture, I think, Professor Jaya. So this is the same project where one of the things to protect the first inclination was, okay, you physically add a barrier, make sure that water doesn't get in. So how you do it? Just put a band it and put it. Some architects liked it, some don't. They don't want the band. So now we have evolved the detail, saying, let's say you do the same detail but put the step inside and work with it and see how it works. The whole idea is water cannot climb up effectively, so make sure that the path is blocked that way. In addition, what we are doing is you do additional treatments at the joint. Now usually you won't do waterproofing inside. This is a living room, kitchen room. As a management, what we have taken the call is, like, even within the flat, if there is a joint, we are treating it. So between living and kitchen also, it's not just between two flats or two living rooms. All entire joints, we are taking that extra precaution and we are treating those. And then subsequent water ponding, select areas and making sure how it works. So that kind of precautions are taken and evaluated. So it's as good as we are building water tanks. Even the external joints, we have a rainfall simulation test, make sure that how the joints are performing for the moisture entry. Now we have that IS 15916, the 2020 version, and now with these requirements are actually incorporated in the IS code itself. So you have the basis to ask the manufacturer or vendor to what kind of or what scale of testing is needed. So those details are available there. Last part of the quality control is we are testing and scoring our own buildings. So we have an in-house system. If you are familiar with Singapore system, they have this CONCOS, which is for conventional quality assurance system. So we have developed based something similar to that, calling precast building quality assurance system. But we are scoring our own buildings for various aspects, structural, architectural. We have our own teams that they go and score these points. Right now, somebody will ask, you are scoring your own buildings, you will give 100 only. So this is not something that client is asking. This is our own initiative, and the idea is I know what I am doing. So Mumbai building I have built, Provident building I have built, and those buildings are scored. Those scores are coming, let's say 85. When you come as a client or as an end user, I'm going to show you the Provident building and tell you that this building is scored at 85. This is how we have scored it. When you get your building, is going to be 85 or more, and there is a basis, there is scales points that physically even client can come in and check it. So the idea is not scoring higher, the idea is creating a benchmark. So next 20 years we have a benchmark saying at least this or better it should be done when it comes to precast construction. So with that, I think we'll quickly go through that SIDCO project, what we are doing, and then the outside world, and another probably 5 minutes and I'll wrap it up. So this SIDCO, what we are doing now, it's a PMA housing project, of course, for that kind of volume, 7,400 units. The total project we took it is about 22,000 houses. An entire thing was supposed to be in precast. That's how we had tendered it. But it came right at the COVID start in 2020. So we decided to split some and use conventional system, because most of our factory, it comes from Europe, the molds and everything, which could not come in time. So later, last year, like I said, about 8 months, we balance scope we have started now. We have set up the factory and we'll be completing about this 7,500 units using this precast technology. So this is the project. If you see all these buildings, all these are the LIG type buildings, and the volume is there. The units are similar, where we can easily adopt the precast technology. These are done by architect office contractor. So their whole goal is, I don't want a typical traditional monotonous building. So they have their architecture. So this is one of the first thing where we are actually incorporating the architectural details in precast. Traditionally, this will be all taken care in plaster works, right? It's easy to do it that way, but it doesn't last. So we took that conscious call, saying I want maintenance free building. So all these architectural features, grooves, everything, we are actually building in the precast panel itself, so we don't have to worry about durability. So this is the factory setup at site. About 2.2 million square foot built up area per year capacity, all molds. Some of them are in-house, some of them are imported. But yeah, these are the buildings. This is about 2 months old photo, but this is what I was telling. The grooves, the bands around the windows, features are all inbuilt, so I don't have to do any plaster work. That's the goal. This is a typical floor that you will see again, these buildings. all flats are same flat. So each floor has 8 flats and all 8 flats are same there. So that's how we are working at it. If you want to look at the speed, this project at its peak, we will be building about 35 floors per month. So if you do that math, it comes to about 10 flats per day. That's what we are aiming and hoping to finish. And that's where the speed comes into picture. Now with that speed and this kind of volume, if you see that entire project, that's 7,500 houses, we are looking at about 1,15,000 elements that will be produced and installed. So how to track it, how to keep track it, your usual day-to-day Excel planning is not enough, your MSP planning is not enough. So we take advantage of this whole digital environment that anyway as a company we are pushing for that, we have adopted that. So everything works on a central BIM model. And then all other these agencies that work around that model, including the reviews, client reviews, progress reviews, factory production, site erection, everything is monitored through. We have an in-house app built for that, and each element is being tracked for its inception to installation. When it was cast, what grade concrete was used, when it was demolded, at time of demolding, what was the concrete strength. Entire history is being tracked for each panel. For the BIM model, if you see, all the drawings are also developed directly through the BIM model. We are kind of shifting away from the 2D development. So the BIM models, if you see this picture, even the reinforcement, detailing, everything is in built the model. So once the model is ready, the drawings are ready, maybe some nominal work, and we take it from there. Then when the action shifts to site or factory, this is the app that we are looking. Like I said, casting, demolding, storage, factory storage, delivery, everything is tracked for each element, item by item, including the checklist are done on the app. How it benefits me as a monitoring or review agency, this is the entire snapshot. If you see this, for this whatever ongoing scope of the month, if I'm going to produce 5,000 elements, I get to see entire thing immediately, live update daily on the phone, saying how many are cast, how many are in the factory, how many are site storage, how many are already erected. So that's how that digital adoption in construction we are advancing it. When it goes to site also, entire tower is tracked, each tower, each level. Nobody is punching the numbers anymore for the status in the Excel. So all they're using, they're flashing their phones. That's the idea, is to using the phone, get that real-time update so you can track your projects well. Once you track those well, automatically the quality control, everything follows, because the checklist and everything is at one central place. So with that, I think now whatever we are doing, of course we are very good with the very comfortable with the technology, mass housing, it works. What next, how we'll see in India is some of these projects I just wanted to showcase. These are all projects that I had managed when I was in US, the architectural projects. So this is something that we will start seeing more and more now that we are comfortable with technology. If you see this picture, everything is precast panel. None of these activities have been done at site. The panel is cast with these forms. Panel is cast with these actual bricks cast in the factory. This entire panel has come as one panel and erected. There is no plastering, no painting. The panel is white cement, has its own color. That kind of premium the outside people are willing to pay because they don't want anything at site. We are still looking at only doing the structural element. This is the architectural cum structural wall. That's where we say the value creation. What you are giving to the client is not architectural brick lay. This is M50 grade concrete inside with a thin brick outside. No painting, no finishing, just joint treatment, and you're done with it. Same this building. If you see, none of the units we are now searching saying precast needs modularity. If you are willing to pay the premium and time, this can be worked out. There are different balconies, different features, entire thing. If you see at the back, this is a parking structure and residential units. Entire structure has been done in precast, factory made, no site treatment. This is another parking structure. Same thing, bricks, finishes,
Amit
all
sir?
whatever bands.
Amit sir?
Yeah.
Sir, where project located in India or somewhere else, sir? These projects?
No, these are all projects that I did in US where I was working with that manufacturing. So these are projects managed by me, but yeah, so future, this is where we are going. Now we are exploring even L&T, we are exploring somewhere we can propose to clients and get through these.
Okay, sir. Thank you.
So this is like the facade for the bridge. So there is a steel bridge and then covered up using precast concrete. This is a hotel building, Gateway Marriott. Again, all external panels with the grooves, reveals, no painting. This is white cement. This is gray cement, sand blasted at factory and installed at site. This is a school building. This is an office building. Again, I said whatever you see, this is dry concrete. So there is no painting again done, only joint treatment, all bands, everything is factory produced in precast. Right. I think we're running out of time, so I'm just breezing through it. But yeah, these are all different. If any architecture students are there, then this grooves patterns behave differently. The architects have their own thing for the shadows and all also, but everything is worked at factory and then installed at. In India also now we are getting this form liner. There are multiple companies where you can produce with these patterns. We are even looking at graphics concrete and all these features. So going forward, this is something exciting that may come up. I think with that I will conclude. I know I have taken more time than needed, but hopefully it was meaningful, helpful. Of course, if you have any questions now or even later, feel free to approach us and we'll take it from there. Thank you very much. Yeah.
Thank you, sir. Pavitra, madam. Sir, actually, I have a question, sir.
Sure.
Sir, can you hear me, sir?
Yeah, I can hear.
Yes, sir. So actually, most of the precast projects what I'm seeing out in Chennai, so the minimum thickness of the RC wall is 160 mm. Okay,
Correct.
sir. Is there any restriction to be 160 mm or shall we increase it? Because basically, I see some two projects for leading builders, which has been completed some 5 years, 6 years back.
Right.
So we can see that some reinforcement protruding out in some stories. Okay,
Correct.
because there is no sufficient cover the RC wall. Okay, so I can see that some of the reinforcement can be seen outside near the toilet walls or near the duct and all. Can we slightly increase the wall to 160 to 170, 170 mm so that we can improve the durability properties of concrete? That's my opinion.
Yeah. See, I think, of course, if it's thicker building, you can do cover also. It will give you more capacity also. One thing is, of course, more concrete, so cost goes up. Second is your weight goes up. So weight is a big issue. We don't have a heavy crane available quickly. If I have to give that idea, if you conventional construction, even aluminum formwork or RC construction, the typical cranes that we'll use is about 2-ton capacity, at the max 3-ton capacity. In precast elements, we start at around 6 ton. And like whatever, even if you take this 160 thick wall or a 4x3 wall, it will go to about 4 to 5 ton. So our whole idea is reducing the weight, because these heavy duty cranes are very expensive. But at the same time, we are evolving. So this SIDCO project that I showed you, now we are doing as heavy as 10-ton elements there, and that has become a norm. But this 160, now coming back to your original question, this is mainly driven by your fire rating resistance requirement for RC.
Yes, I know.
You see 450.
But when it goes with zone 5, I think the wall things will be more higher, am I right, sir?
Yeah, the tall building code, if you see now, the tall building code is there. That is that 16700. That is saying 200 thick wall if it's zone 4 and 5.
Okay.
So that, yeah, of course. But 160 also, the issue that you mentioned, the rebar protruding, that's another issue. 160 wall also can be detailed comfortably with even 30-35 mm cover. We are doing some places 40 cover also one side. But you have to have your QAQC and check and make sure that reinforcement is not exposed.
Okay. Thank you, sir.
Sure.
Good morning, sir. This is Dr. Dinesh from NIIT at Chennai.
Hi, good morning.
Very nice presentation, sir. Thank you very much for sharing your experience with us. Actually, I have some of the questions. Say, whether it is possible to construct the basement floor?
Yeah, basement floor also possible to construct, but like I said, usually basement will have earth retaining, so the thicknesses go up. So 200 to 250 thick, your weight goes up. So we have done some cases even retaining wall. I have done an 8-meter tall retaining wall, but then that was split into different elements. It has its own challenges. Now, why we don't usually do in our buildings is, see, the kind of model we have adopted. We set up the factory at site. I don't have a central factory, so I don't have to worry about transportation. Now, by the time my factory is setting up, it takes 3-4 months at least. What we do is parallelly we do basement and first floor construction in cast in place, so I don't have to wait. But there are many vendors who are doing basement walls and all in precast also.
Okay.
You have to have
One more question.
extra attention for the joints, and because there is active water membrane waterproofing and all. But yeah, you can do it, detail it. No issue.
What about the expansion joints, sir? So when you are constructing 20 plus floors, 15 or 20 plus floors with the help of this precast elements,
Right.
then the overall length will be much more. No, sir? Height will be much more.
Yeah.
So what about the expansion joint?
Yeah, expansion joint we detail as similar to your conventional system. So our buildings now, that Mumbai building, what you see is actually 20 flats, so about 80-meter long. There we did not have luxury of expansion joint, so we did the temperature analysis and provided extra steel as needed. This Sidco buildings that I showed you, that between two buildings there is an expansion joint, so we have done that detailing and erected precast elements against each other.
Okay, so we can do it in horizontal direction as well as the both x and y direction. But in the height wise, when you go for height wise, how it will be behaving?
Yeah, height wise, once I put the expansion joint and I designed those as two separate buildings like conventional system also. So we don't have any particular issue. There is no joint anything between. Vertically building is continuous and monolithic. There is nothing in between. Only the horizontal joint expansion we added. We analyze these buildings as two separate buildings. And we look at that for tall buildings, especially the gap of expansion joint has to be analyzed. And usually we provide 2 times the maximum deflection of one building.
Okay. So you have worked in the USA.
Right.
Is there any the prefabricated? Some people are talking of nowadays. The entire the cabin we can arrange with the help of this kind of precast element, box kind of a thing. They can do it. Is it there is a possibility to come that kind of a thing in our India? Whether it is already came
Right.
or not? What is your opinion?
Yeah, I think that is known as the PPVC, is prefabricated, pre-finished volumetric construction. This is mainly driven by Singapore. So Singapore has been doing that for last 10-15 years now. The government mandates it, right? So the way these things work is government says, this is how I want to build. I want to build faster. I don't want you doing 100 activity at site. So you go finished. So there, the way it started, they were saying that entire room, all finishing tiles, everything installed, you bring it and assemble it. And there were projects where they say you have to use this. There is no other go. So the vendors that we have talked, the precast vendors, they were initially, this was in 2014, and he's like, I don't like to do this. There is a lot of intricate detailing, cumbersome activities, but my government is pushing it, so I am doing it. So that has been driven from the top by the government. Now it is being done at will. So even the vendors are doing that because it reduces the activity at site. So this bathroom unit that I showed you, this is kind of a smaller scale of the same concept, the PPVC. This one unit that I showed you, it after the finishing, it's about 2 meter by 1.5 meter footprint. It weighs about 10 tons. So if you look at entire room, the Singapore they operate at 25-30 tons units also, but that kind of infrastructure is there. They have cranes available. If we have those resources available, reasonable, if it makes economic sense, we can do it. I think there are some people who are already doing also. If you see, government of India announced this global housing technology challenge for housing. They are already doing some 5 lighthouse project. If you research GHTC, there is a website also. And one agency is doing this 3D modular concept pre-finished. One project in Ranchi is going on already.
Okay. So the one final question.
Sure.
Actually now in the conventional building and all, we can design for 10 floors. Now we can construct the 5 floors. After some time, after some years, we can extend the another 5 more floors. Is it
Right.
possible to do in the prefabricated? precast?
Yeah, I think design wise, planning wise, not an issue. Only your hurdle or constraint is going to be your crane, because these heavy cranes usually at the center of the building or out of the building. That assembling the crane and all, it doesn't make economical sense to do that.
Actually, to place the precasted walls, we have to leave the double bars and all, right?
Correct.
Say, when after completing the fifth floor, I'm leaving this double bars. Say, what kind of
Yeah.
a precautions I have to take to safeguard this from the environment?
Yeah. So I think this is an interesting question. We had that one. We finally did not do the project, but we had the exact same request saying you build precast now, but I want to add 2 floors later. That hostel is a different example that they during execution itself they said you go ahead and add. So what we had proposed was, I will build precast 5 floors. I will leave the dowels reinforcement such that you can come and build using conventional system on the top of it. So you don't need the heavy crane. You can still do conventional beam columns and block work and work it out. Now your structural analysis and all becomes very complicated because now you have 2 different systems and all. But we had done that analysis and given the option. The job did not go to construction, but you can do that kind of work. So you don't have to be tied or constrained to precast system only. If they want to do precast also, they can do. Otherwise, conventional also can be done. And doing conventional by a third party is much easier option than doing precast by somebody if you want to just add 1 or 2 floors.
Okay. Thank you, sir. Thank you very much for your nice presentation, and thank you very much for your sharing your experience with us. I also
Sure thing.
thank
You.
the Kannan Rajkumar as well as Gunasegar sir for giving me this opportunity to attend this program. Thank you.
Okay.
Thank you, sir. Thank you for coming, sir.
Yes, sir. Thank you.
Good morning, sir. This is Dr. Asha from St. Peter's. Amit, sir, you mentioned about a building in Mumbai which has been designed for seismic loads in the zone 3. But it was constructed 43 years ago. The codal provisions for the earthquakes were in existence only for the last 15 to 20 years. So how come it could be designed for earthquakes in such a long period before?
No. What I meant was that building is been standing in a zone 3 area. At that time, prevalent codes, they did that. If you see, I think there is, if you look at a Shirish Patel paper, there is an entire paper how they address the seismic design. And they have done a full scale lateral load test before they started doing this construction. In that paper, you will delimit. They were not per the IS code or anything, but at that time prevalent, there was code, there was requirements. They did the testing. They actually built the vertical wall panels and pushed it laterally and verified and everything, connections and all. It's a very interesting paper. You can look it up.
Yes,
Just,
I will refer it, sir.
Yeah.
I have one more question. Like in the conventional buildings, after 20 years, like we have repairs and renovations, and we carry out with the plastering or many other techniques we have. In the precast buildings, how do we identify if there is any repair in the connection details, particularly? How do we come to know how to repair it? Is there any case studies available, sir?
Yeah. I think, see, I keep in most forums one thing, and take this comment judiciously, but precast concrete is much less forgiving than conventional concrete. I think if you evaluate that, if there is something wrong, precast concrete is going to immediately show it to you. Conventional concrete, even if you do mistake, the one bar is here, there missing, you will never know building will perform. In here, your joints are vulnerable to cracking if there are excessive loads. You will see that. So what we usually suggest is your nominal maintenance is really important. So if you just visual inspection, let's say commercial buildings, the glass facade, they keep maintenance every 6 months. Here we don't need every 6 months maintenance. You have to every 3-4 years just visual inspection. If there is anything seen, let's say for example grout is there, if it is extra or if it is not done well, you will see the grout cracking and all those areas you will have to maintain and replace it. If your building has sealant, sometimes the sealant, if it is overstressed, it will tear. Then you go local area and replace that local area sealant. So that maintenance is key. Usually when we hand over the buildings, we are giving these specific instructions to the client too. That is something you cannot escape. So that has to be attended.
Fine, sir. Fine, sir. And last question. You mentioned about the tall buildings in the precast construction. Is the connection detail in the first floor or second floor is the same for the 17th floor?
No. Yeah, they are very different because your loads are heavier at the bottom. So you kind of, that is the engineering where again, if you say conventional building engineering, you will do same design for first 7-8 floors, then maybe transition, go another 10 floors, then 10 floors, and even the analysis is done that way. If you see precast buildings now, our engineering design team will go joint by joint each building. These buildings are getting looked at even more, I think 10 times more critically than a conventional building. Joint by joint we are evaluating the loads, and then joint by joint, as it makes sense, we actually transition. So usually first 2-3 floors will have somewhat similar, but even there within the panels there are intricate changes. But overall building, as you go up, it gets lighter and lighter.
Okay, sir. Okay. What design code you follow for the design of this connections in the tall building, precast buildings, sir?
Yeah. So current Indian codes, of course, 456 is the main basis. 13920, if it's ductile detailing, that you cannot skip anymore. For precast specific, like I said, 15916 is there. It kind of covers design plus your structural integrity, serviceability requirements. There is 11447 is there, which is an old code, but it talks a lot more about design detailing, connection detailing. That is there. Beyond that, if you see precast PCI handbook is there, of course ICI handbook is there, that's an excellent resource. And then Eurocode 2 also talks a lot about precast system, so we kind of adapt and mix and match for our requirement.
Thank you so much, sir. Thank you for a wonderful presentation, and thank Dr. Gunasekaran sir and team for such a wonderful webinar. Thank you so much, sir.
Sure thing, thank you.
Kannan sir.
Sir, there are a few questions in the chat box, sir. I'll read it out for you, sir. Are you using any heat insulation material for RC wall to reduce the heat or temperature in the room?
Yeah, this one cladding job I showed, the 1000 element job and all that, actually the spandrels and all have insulation inside. Currently we don't get any specific premium from client for heat insulation, so we are doing it only to reduce the weight. But like I said, that future is coming. Your all energy requirements, the government is building 5 years down the line, you are going to see that enforcement. And it's a very common practice to use insulated systems in precast. That is something that you cannot do conventional system easily. But precast, if you see all these jobs that I showed, outside jobs, that brick wall panels have insulation inside, and that is by default in US because the government mandates it. This LEED certification and energy requirements. In India, that is not very popular yet, but it's coming. There are a lot of people working on it, and then it will become a norm of choice going forward.
There's also one more question, sir. What will be the guaranteed life that you can suggest? Can you certify against natural hazards like earthquakes, flood, fire, etc.?
Sure. Yeah. So again, like I mentioned, this is emulative design, RC construction. So our code, actually there is no specific requirement, but usual practice is 50 years of life that comes from the wind code. So that 50 years is matched for the precast buildings also. So anything that is not replaceable is guaranteed for 50 years of life.
Thank you so much, sir.
Same
Thank
for
you.
lateral or natural hazards, everything.
Thank you, sir. Thank you, sir, for enlightening us with your knowledge on precast elements, especially on the design methods and detailing procedures, and telling us the comparison on ductility between the in-situ concrete and the precast elements. Thank you very much, sir.
Sure thing. Thank you. Appreciate it. I enjoyed it.
Thank you, sir.
Thank you, sir. Amit, sir. Thank you, sir.
Sir, shall I proceed, sir?
Yes, madam.
I also take a privilege to welcome Dr. Mohammad Abdul Mannan, Professor, Department of Civil Engineering, Faculty of Engineering, Universiti Malaysia, Sarawak, Malaysia. Now I would welcome Dr. K. Gunasekaran, sir, to introduce our speaker. Welcome, sir.
Thank you, madam.
Thank you, sir.
Is the screen is visible to all of you?
Yes, sir. It's visible,
Yes,
sir.
sir.
Okay. I am very glad to introduce that Professor Mohammad Abdul Mannan to the participants. Professor Dr. Mohammad Abdul Mannan is a professor in the Department of Civil Engineering, University Malaysia, Sarawak, Malaysia. He is having more than 30 years of experience in both teaching and research. His major area of specialization is on concrete materials, lightweight concrete, oil pump shell concrete, structural failure and analysis, precast concrete, green buildings and pavements. He completed nearly 13 research projects costing around 10,89,898 Malaysian ringgit so far. He has published many research papers. Most of them is highly reputed SCI index journals having highest impact factor and SNP values. He is a peer reviewer for many journals. He wrote a book named Oil Pump Shell, Lightweight Concrete and Structure. He presented many articles in many conferences, both international and national, as a keynote speaker. He innovated a cylindrical detention pond, that is what we call CDP, as an innovative green pavement system. And for that, he got recently awarded 2 gold and 1 best award for the same from Malaysia Technology Expo 2021. He also developed a permanent formwork, the corrosion resistant panel. He has made a 8-meter span reinforced C channel full precast floor panel using oil pump shell concrete. Professor Abdul Mannan sir also developed a storm pipe related to rainwater harvesting through the pavement and made a tie-up with a company. And for that, he already received 2 rounds of royalty and has got license from his university. He has many research patents in his career. He has many professional body members, especially he is a member in Institute of Civil Engineers, which is not easy to get by anybody. It is very difficult to get it. He got that membership from Institute of Civil Engineers. With this brief introduction, once again I welcome Professor Mannan sir to take over the session.
Thank you, Professor.
1 minute, sir. I'll close it.
Assalamu alaikum warahmatullahi wabarakatuh and good afternoon. Here is afternoon. Okay, I need to open my slide.
Yeah. Yes, sir, you can share it now.
Okay. Can you see this one?
It is sharing, sir. Now it's, yes, sir.
Can you see?
Yes, sir. You're able to see.
Thank you very much. First of all, I have to say salute to my previous 2 speakers. They have given us a lot of research foods for our next level of thinking on the precast industry. So anyway, I'm going to share my little thought. I'm not taking long time, short time. This is the research I did at my previous university, University of Malaysia, Sabah. The name I put this product is Precast Sigon Sofa. My intention was about this addressing the mosquito problem. Mosquito is everywhere, but we are not expert about this mosquito. We are looking in the structure, how the structure can produce or can eliminate this one. So mosquitoes cause serious problem to human and other animals globally. It breeds in standing shallow water, particularly in summer monsoon rain that stands more than 3 days. As soon open drains in flat land cause water stagnant, favoring mosquito breeding. That I have seen. The best way to eliminate mosquitoes is to eliminate the breeding sites. That I'm looking from my structural civil engineering point of view, how I can eliminate this element. Let's look into the conventional drain favoring mosquito breeding. The design here, the drain on flat ground having very gentle slope. normally 1:200 or 1:210, something like that. That's impermeable, meaning water has to go to longitudinally. It cannot go other way. And also the evaporation, that's the way. Look at another drain, the filled drain favoring breeding of mosquitoes and other insects seen very open in conventional drain system. If you look into this one, this is the roadside, the drain is there. So it also health risk. This is the issue I look into how we can solve this one, because that structure comes from the drain. Look into again. In the drain also there are a lot of countless insect larvae here in this stagnant water. And we people are educated. Our intention always to throw this rubbish into the road, or later it will go to the drain. So now this one happening. So it also causes strong this concept is housing area. These are my issues how to address from civil. Then we make this product. It is made the first product made of oil palm shell, because my research started with oil palm shell lighted concrete. The product I made with oil palm shell and more made fast. So my student only, my final year student, young Liz, son and me, we two are here. So then gradually we have gone to some, so we discovered this product is cost and time saving as IBS product. And that those days we started using handmade. That particulars, the name we have given sequence of potential applications. I have not done all because I have left that university. Now is another university. I cannot continue that same research here because it's a patent. So look into mosquito drain for
sir?
normal purpose.
Sir?
Sorry.
Sir,
Yes,
I'm
can you hear me?
Your voice is slightly breaking, sir.
Can you hear me?
Now it's okay, sir.
Okay.
Thank you, sir.
We look into this, the same product can go several applications. As anti-mosquito drain, that is our initial thought. Then it can go for drain normal purposes, or retaining wall, or slope protection, or embankment protection. Depending on the orientation of this product. Record blocks in unit area construction, we need 9.8 number block to make 1 meter square wall area. And we can make 55 numbers of block using 1 cubic meter concrete. And using 55 meter blocks, we can cover about 5.6 meter square wall area. It depends on, it is a non-structural concrete. I do not need steel rod. I am not worried about this corrosion. Then I look to lowest grade of concrete because I started with oil palm shell. In that sense, material is definitely cost effective. And the weight of that block is around 40 kg. And this product was brought to Geneva, Switzerland for that international exhibition, and it obtained bronze medal. Sequence of an IBS product is used as a retaining wall without using any mortar to retain earth. This product satisfies the requirement of retaining wall structures. Drain made of precast drain beds and these blocks enhances self-drying through side and bottom seepage during rain as groundwater table is quite below, especially in summer. It has features of modularity, adaptability, portability, and self-interlocking. This product has performance absorbing minor movement due to dry stack flexible structure because interlocking. Cost-effective point of view, dry stack without using any mortar, use of ordinary grade of concrete, saving instruction time and manpower about 1/3 of conventional system. Massive because we can produce big number. Then aesthetic point of view, ensuring beauty at exposed phase. Environmental point of view, eliminating mosquito and insect larvae breeding. Then user and environmentally friendly product. Installation is very rapid and simple. I have tried, done 30 to 35 meters per wall area can be done by 2 persons with a simple lifted device. Market point of view, high potential because industries are in line with my previous university. They are pushing me to continue. This is my product. It looks like a sitting sofa, actually. Single sitting sofa. If you look into this one, a person is holding that block. This is the mass production. It was done manually using a normal mold. We put this. Look at this one. Also, compared to stacking, we have done stacking was done 7 days and used daily cast 2 times. The first set was demolded after 5 hours 30 minutes. Then second set was cast on the same day. And we put this concentrate stacking on the second day. We have looked at the complete white mix. We did that one to set our mold cost. We have also looked into this can go for many types of process, maybe maintain. The drain width can be 200 or like 300, the drain bed width or 700. We look at everything is precast. The precast is also precast. That cover also precast like this. We look into, and inside we can fill infill material. We look into this one, or our drain width can be 1,500 or 2,000. We look into several values. But precast component, like the holding that bedding one, is the same size. Then we look into the drawing, the 3D view, how this can be arranged. Then we also look into the arrange how back is seen. We did like this one. Then we made also the mock. Before the mock, it is a 7 meter long, about 1 meter deep. We consider is 120 units. The block we have used to look into to see whether particle how many numbers we can put there. Then after that we put also sometimes in the drain we need the cover blocks. Then we put some also cover block whether it can be there or not. We did that because our money was limited. We look into optimization on that money. Then we have gone a company is Uganda. That person passed away just 3 months back. So that company got this license from a previous university. Then the Binapur, one of the biggest construction company in Malaysia, they consider this product. The based on that, they say being 100% precast products, including bedding block, it claims mandates involvement at installation is about 1/3 of conventional cast in situ concrete. This is Binapur's comment. This is the conventional RC retaining wall. And also after retaining wall, there was RC drain. It was their original drawing. That Binapuri saw my product, they approached to me why that my product can be used there or not. If you look into it is about 2 meter deep, 2 meter deep. Look at this amount of soil should be removed. They have to cast this RC part. Quality cannot be maintained. After completing, again they have to cast this drain. Meaning they have to go there 2 times. And mostly it is a structural product. A structural product is how we say airports bending moment. And for that we need reinforcement. Once reinforcement, I have to look at quality in the sense of durability. That's why we say it is a structural product. Then I have made this drawing for them and they're satisfied. This is 2-in-1. It acts as a retaining wall and also, hello.
Yes, sir.
Can you hear me?
Yes, sir. Can you hear you? Yes, sir.
Okay. Okay. Then I look into based on that. We have this one. All the blocks are precast. The bedding also precast. Like this. One side is a parking, another is considered the building wall. So we made this one basically the retaining wall. You have to look into safety factor sliding and overturning, and also surface load. So for this reason, we use 10 kilonewton surface load to see to get the satisfaction. Because we have produced the block, then we started with the 3 workers. Ordinary workers know that they are not skilled workers because this is a labor. They have to simply assemble there. So they have started. After that, the rain started. On the rainy days, the people also started doing. These people belong to another company because they have to do that side. So my staff, they are doing assembling here. So during this rainy days. Because this first project, we had the difficulties here, I have to say, because there are several molds. All molds are done manually. All molds are not same. That's when you go to fit, it does not fit properly. It took little extra time. But later on, we solve the problem. This manual problem. Then you just look into steel backfill was not done completely. Several layers were there.
Excuse
That
me,
means
Prof.
they were
Mannan.
standing. Yes.
Hisham here. Your voice
Yes.
is not very clear just now. Maybe if you turn off the video, the audio will be okay.
Okay. Okay. Can you hear me?
It's clearer now. Okay, thank you, sir.
Okay, thanks. Okay. Just look into this one after completing. This is the L pattern of the drain cover retaining wall. This is the deeper side. It was installed in 2010. Then those days the vice chancellor here with his blue shirt, he came to see that one, how the progress was there in December, I think. He came here to see that one. So we took this one. Let's look into, then after that, after our work, then other works also done. This is not a complicated because this is non in steel rod, very simple one, but because the drain was L pattern, how is the connection? Those days I did not look into the connection, I looked into my product. Then connection, at this point, we did consider using the conventional system because there is another underground pipe is here. So we did here, this is considered some, we put this casting sheet decol and just we adjust. Then after that, just look into stopper drain because from the car park, the water has to come. Then initially I did not think about whether I need a consider hollow or not. Then after that, we hacked that portion to fit this one because this was the first project. Just like look into this one, because scupper drain is here because water has to come. Another disadvantage we saw in this project, because once they place this one, they say the drain bed is quite below than design invert level. Then that's why they create this concrete to get this level, because that side, the lower side, this one is far below than lower side. That's why they fill this portion. You can look into this one. Because the system here, I have not seen water holding that. That's what we call is considered into mosquito. You see this one here, it is always a dry condition. Now this photo taken this year, I asked someone to send photo. It was designed, built in 2010, and this is 2021. You can see the maintenance period. They do not go do any maintenance except grass cutting. Like this one, this is the bottom side because water is continuously coming from that side. Here we can see this water, but another side there is no water. Here also, if you look into this, the green, they keep on cutting. So if we allow this grass to grow, then heat swing can be minimized as a green product. You can look into the surface load application, meaning the parking area. They place their car like this one. It is in one sense consider that surface load is okay. Then look into, sometimes they put also that motorbike. Then we look into whether we can go for other applications or not. This is the one main drain at my previous university, is a made of rubble wall, and the top, the height is 2.7 meter deep and the top is 6.15 meter wide. I thought maybe I can propose using my blog, and I propose to authority. It is up to them because it is already made, so they cannot replace using my idea. But I have given them idea. In another project, we tried, but the cost is high. That's why they did not consider. It was about 2 kilometer retaining wall project in Sabah, and at the time I left. So due to miscommunication, we could not manage this one. In the same arrangement, it's a 2 meter height retaining wall can go using that my system. We have proposed that client. Like this, and how this can go. Further, they look into cast in situ bedding. Then I propose them cast in situ bedding can go. Then another project was there. They are looking into gabion wall 3 meter deep, 3 meter deep. Then I say I can propose like this, because finally they have considered, because the gabion wall is considered cost effective because of the wire mesh, to put the rubble and fix. But to me, it does not look nice. I proposed another company can go like that, but it did not materialize because I left that place. It needs continuation. Okay, just look into from the design point of view, the written one structure. We have to look into sliding factor and overturning factor, and including surface load. We consider different height, 0.5 meter to 3 meters. Our normal drain is considered at the most 1 meter drain, roadside drain. Then I look into different height and also that the angle. We have provided 70 and also other. Then we also provided the surface load 0, 10 and 5. Then we look into safety factor sliding and overturning, whether it is more than 1.5 or not. Then we have got this. Then look into, if I go like say 3 meter height, then I look at a surface load, because anyhow safety factor and sliding should be more than requirement. Then I have also gone 68 and 65 degree that slope. Then we have got the satisfaction. Side C area, and I propose like this for the same company for road repair. Then look at this product also can go for slope. Sorry. Then I look into my product should go also another application, slope surface protection, because in Malaysia, particularly Sabah, there are more than 500 locations have slope problem. Because always slope failure or landslide happens due to prolonged heavy rainfall. Infiltration impairs slope stability during high rainfall. Rainfall duration and intensity, slope surface, degree of saturation, slope angle, permeability and water table signify slope stability. This research was done, this goes here, my one professor at UPM, in field conditions, he used 122.4 meter rainfall intensity, and at site, he has also used different kind of covering. And infiltration rate, he has observed natural grass with the geosynthetic net, he has seen infiltration rate 3.24, 25 mm cut grass with geosynthetic net 7.2, geosynthetic net alone 10.84, and bare slope 24.88, meaning if it is bare, the infiltration rate is quite high. Then look into slope failure. So we look into widespread occurrence of landslide is associated with slopes and heavy rain. Okay, like other countries, like in Sabah, Malaysia, conventional buildings, roads, etc., across hilly area, which are involved cutting slopes to a certain extent, cause occurrence of landslide more frequent and visible. The same story, I'm not reading this one. Same. We look into how they do that covering. Normally in Malaysia, that slope surface is covered by vegetation or rigid surface. Vegetation surface, normally they go signal grass and also legumes. They use this type of vegetation surface covering. Another shotcrete or masonry as a rigid surface, normally they use. Shotcrete or masonry or stone piecing is used as a rigid surface protection. This system is highly impermeable. Weave holes are provided at a regular interval at horizontally and vertically to reduce build-up pressure on the slope during rain. Sometimes soil nailing is also done, including shotcrete application. Hydroseedings they are also doing, like grass rooting or something like that, they do for protection. So I look into a different point of view, because my product, if orientation goes deeper and then it looks like fish scale. So I look into conceptual approach for the slope surface protection using my blocks is shown in the following figure, but it needs investigation to fulfill the requirements as per the construction industry, because I have not done any work on the slope surface protection. Just look into conventional system, people are doing this kind of grass seeding, because a seed for grass to grow like this one, conventional, but again landslide happens. They also go Mucuna bractita, that consider that planting they do. After that we can see this is also another kind of slope surface protection. Again we look into this one, conventional practicing, but slope failures are seen. Or look into this one, though they have given lining, but all slopes are failed. because this highly impermeable surface. Also look into this one in the University campus. These are they are considered short area including wing folds. Then I look into my product may go like this, like a fish. I can look into similar arrangement. When the rain happens, water cannot penetrate inside. That's my concept. I have done little more something like that. My product also can go here or they consider retaining structure area. We can use also like this concept, but I have not done. Then look at this one. If you make this consider slope surface, the appearance will come like here. Then we also have to provide consider cascaded drain. I have provided at the side and also bottom drain. Like this. If the slopes are many layers, then we provide this one, including consider B interruption, the B drain at here. What I'm saying, when the rain happens, water will not go inside. I claim, but I have not done. But again, another beauty part, the built-up water table gradually can go out. So shear strength remain good condition for the slope or hill. The front view will be like this, like exactly our fish. Or maybe if necessary, they can go for nailing or anchoring. So I have given some idea how this nailing can be done. Front view of the nail surface can be looked into in that manner. All done, but I have means in the concept of my table study, but I have not done this. Another project also came, this existing building, Jesselton Conduit Sabah, this existing drain, they asked me to fit here. So I proposed, but after that I left that location. That is all, very simple. Thank you.
So thank you so much, sir. The forum is open for questionnaire session.
Sir, I'm Kannan. So what is the minimum grade of concrete used in this project, sir?
Because I started with oil palm shell. That's my first dream because it is a grade 22.
How much, sir?
22. Because it's non-structural.
Okay.
22.
How about the bonding between the elements, sir? Interlocking only. So
this interlocking.
Have you designed for the
shear key.
lateral pressure also, sir?
Through shear key, I have provided that shear key in both sides.
Okay.
Interlocking shear key.
Okay. What is the maximum height you have done, sir, as of now with this technology, sir?
Actual project we have done 2 meters.
2 meters. Okay.
The project I have shown 2 meters, but I can go 3 meters.
Okay. That means lateral pressure can take up by interlocking.
Yes.
Okay. Thank you, sir.
So there's a question in the chat box. Do you prefer this for roadside drain as a replacement for RC drain?
Okay, you have to look into the surcharge load, how much is coming. Then you have to calculate. Roadside drain means the surcharge load. How much surcharge loads are coming from and how far or how near that drain. You have to calculate, then definitely can go.
Thank you, sir.
Sir, what about cost effective, sir, for this technique?
Cost point of view, if you look at the matter, we are looking at the lowest grade of concrete, like say grade 20, for example, according to the design guideline, grade 20 concrete. For that drain purposes in Malaysia, they say grade 20 concrete. If you look at the grade 20 concrete, then I'm looking to my raw material. Like say here I look into oil palm shell, but I look at conventional material. Then you look into the cement content, how much. Easily you can estimate, but using 1 cubic meter concrete, I can make 55 blocks.
Okay, sir.
Meaning like you can also use coconut shell to make that system.
Definitely, sir. We'll try. Thank you. Thank you, sir.
So thank you so much, sir. Thank you, sir. You need not need a special mention because you are always a part of our SRM family. We thank you from bottom of our heart. for sharing your enriching knowledge, sir. Thank you so much, sir. The
Shall I stop this sharing?
Yes, sir.
Yes, sir.
Okay.
The feedback form is posted in the chat box. You can fill the feedback form to receive the certificates. The certificates will be received in 7 working days. I kindly request the participants to fill the feedback form that's been posted in the chat box.
Professor, sir, if you want, you can leave, sir. Take a leave from us. Thank you. Thank you very much, sir. Thank you. Thank you, sir. We'll meet, sir. Thank you.
By the way, give a water thanks, madam.
Yes.
Oh.
I have not taken my lunch. I have to take lunch now.
Oh, it is too late, sir, for you. Now around 3 o'clock.
Okay, thank you.
Just a minute, sir.
Sir,
Madam,
thank you so much, sir. Sir, you were always said no to our
Yes.
wishes. You always fulfilled our wishes. You're always a part of our SRM family. Thank you, sir. Thank you to gain knowledge from you, sir. Sir, I'll propose the vote of thanks. The end of the story is the new beginning for many others. On behalf of our Department of Civil Engineering, SRM-IST, in association with Universiti Malaysia, Sarawak, Malaysia, and Indian Concrete Institute and UltraTech, I propose the vote of thanks for the virtual international webinar on Precast Concrete Technology. We sincerely thank the dignitaries for being with us and enlightening us with their enthusiastic remarks. I would express my gratitude and thank to all our invited speakers, Dr.K.P.Jaya, Professor, Engineer Er.Amit.K.Barde, and Professor Muhammad Abdul MANNAN, sir, who despite their busy schedule has found time to grace this occasion by delivering a wonderful lecture. I shower my heartfelt gratitude to the convener, Dr. P.T. Ravichandran, Professor and Head, Department of Civil Engineering, SRM-IST, the coordinators, Engineer A.P. Murugan sir, UltraTech Cement, all our assistant professors. A special mention to Professor Muhammad Abdul Mannan sir, UNIMAS, and everyone of SRM-IST family for their wholehearted support rendered in the success of this webinar. Thank you so much, sir. Thank you all,
sir.
and
Thank you.
also have a wonderful day.
Bye, sir. Bye.
Thank you. Thank you. Bye, sir.
Okay. See you
Yes,
again.
sir. Definitely, sir.
Yeah, thank you. Thank you very much. Have a good day.
Thank you, sir.
Thank you, Amit, sir. Amit, sir. Thank you, sir.